Before we begin, if you're enjoying this content, using hype points on this video helps the channel more than you possibly know. Seriously, it makes a massive difference in reaching new listeners. If you're tuning in on Spotify, leaving a review helps out so much and is incredibly appreciated. Also, if you feel like it, drop a comment letting us know what time it is where you are and where in the world you're listening from. We absolutely love seeing where everyone is tuning in from across the globe. And of course, if you enjoy these stories, subscribing really helps us continue making this content. Also, before we begin, a big thank you to Jeff Anon for suggesting this topic. Alright, let's get into it. Imagine you built a machine to watch your neighbours, not to spy exactly, just to see if anyone else was home. You point it at the windows across the street and you leave it running for years. Day after day, it records, it catalogues, it watches. And then one night, you're reviewing the data and you notice something. A pattern in how the lights turn on, a rhythm to the curtains opening. Movements that seem, in some small way, responsive to your observation. And you realise they know you've been watching. That's the Kepler syndrome. What I'm about to share isn't classified. It's not hidden. In fact, it's all public record. NASA published it. Scientists celebrated it. The data is freely available to anyone who wants to look. But somewhere in that openness, in that flood of discovery, a question got buried. What if finding them meant they had already found us? The telescope that looked back, Chapter 1, the birth of the Kepler mission. In March of 2009, a Delta II rocket lifted off from Cape Canaveral carrying a payload that would fundamentally change how humanity understood its place in the universe. The cargo was a space telescope named Kepler, and its mission was deceptively simple. Determine how common Earth-like planets are in the Milky Way galaxy. The launch window was precise, the trajectory calculated to the second. Everything about the mission radiated careful planning, the kind of preparation that takes decades to execute properly. The telescope was named after Johannes Kepler, the 17th century astronomer who discovered the mathematical laws governing planetary motion. It seemed fitting. Kepler the man had revealed how worlds move. Kepler the machine would reveal how many worlds exist. But there's something worth noting about the choice of name. Johannes Kepler didn't just observe, he interpreted. He took the data collected by Tycho Brahe and saw patterns others missed. He found order where others saw chaos. The telescope that bore his name would do the same thing, and like its namesake, it would reveal truth that made people uncomfortable. The mission design was elegant in its specificity. Rather than scanning the entire sky, Kepler would focus on a single patch of space located between the constellations Cygnus and Lyra. This region, covering roughly 1/400th of the entire celestial sphere, contained over 100,000 stars. Kepler would watch them all simultaneously, continuously, for years. Think about that for a moment. One narrow slice of sky, unblinking observation, for years. The method was called transit photometry. The concept is straightforward. When a planet passes in front of its star from our perspective, the star's light dims slightly, very slightly. We're talking about brightness changes of less than 1%, sometimes much less. By measuring these tiny dips in brightness repeatedly over time, Kepler could detect planets billions of miles away and determine their size, orbit, and position relative to their host star. The telescope didn't need to see the planets directly. It only needed to watch for the shadows they cast. The instrument at the heart of the mission was a photometer with a 95 megapixel camera, one of the largest ever launched into space at that time. It was designed to measure the brightness of stars with extraordinary precision, detecting changes of just 20 parts per million. To put that in perspective, that's like noticing a single light bulb being removed from a sports stadium full of them, from space, continuously, for years. The scientific community framed this as pure observation, passive data collection. Humanity pointing an instrument into the void and simply listening. But listening, as any intelligence agency will tell you, is never truly passive. Observation is an action. Data collection is a choice, and choosing what to watch means choosing what to know. The mission was presented as a census, a galactic survey to answer one of the oldest questions in human history. Are we alone? NASA's public materials described it as a search for Earth-like planets. The goal was statistical, to determine what percentage of stars have terrestrial planets in their habitable zones. Simple, scientific, uncontroversial. What wasn't discussed, at least not publicly, was what we would do if the answer turned out to be no. Or more precisely, what we would do if the answer suggested we were already known. The planning for Kepler began in the early 1990s. Proposal documents submitted to NASA outlined the technical specifications, the scientific objectives, and the expected outcomes. Funding was secured, partnerships were established. Engineers and scientists spent over a decade designing, building, and testing the spacecraft. 15 years from concept to launch. That's a long time to prepare for a mission that's supposedly just counting planets. William Barucki, the mission's principal investigator, had been advocating for this type of mission since the 1980s. He faced rejection after rejection from NASA review boards. The technology wasn't ready, they said. The science wasn't compelling enough, they said, but Barucki kept pushing. He refined the proposals. He improved the technology. He demonstrated that transit photometry could work, and eventually NASA agreed. The interesting part isn't that Barucki was persistent. Lots of scientists are persistent. The interesting part is the timing. Kepler was approved for development in 2001. Construction began in 2002. The mission architecture was finalised in 2003. All of this happened in the immediate aftermath of accelerating exoplanet discoveries using other methods. The first confirmed exoplanet around a sun-like star was discovered in 1995. By 2000, dozens more had been found. The field was exploding. Suddenly, the idea of searching for Earth-like planets didn't seem speculative anymore. It seemed urgent. And when institutions move from skepticism to urgency that quickly, it's worth asking what changed. Chapter 2. Watching one patch of sky. Kepler's field of view covered approximately 115 square degrees of sky. To put that in perspective, that's about the area covered by your hand held at arm's length. In cosmic terms, it was a keyhole, a narrow window into one small corner of one spiral arm of one galaxy among billions. And yet, within that keyhole, Kepler monitored over 150,000 stars. The telescope achieved orbit on March 8, 2009. By May 2nd, the photometer had been activated. By May 12th, Kepler had collected its first science data, and from that point forward, for years, it never looked away. Every 30 minutes, Kepler took a full-frame image of its entire field of view. Every pixel was recorded. Every star's brightness was measured. The data was stored on board, then transmitted to Earth via the Deep Space Network, NASA's array of massive radio antennas scattered across the globe. The transmission schedule was carefully managed. Kepler would observe continuously for months, storing data in its solid-state recorder, then pause to download everything to Earth. During these download periods, which lasted several days, ground teams would process, verify, and archive the data before the next observation cycle began. By the end of the primary mission in 2013, Kepler had collected more than 2,000 gigabytes of raw photometric data. To put that in context, that's equivalent to roughly 1 million photos from a modern smartphone. Except these weren't vacation pictures. These were precision scientific measurements, each one representing a specific moment in time for over 100,000 stars. Thousands of researchers around the world gained access to this data through NASA's archives. It was public, open. Anyone with the right software and enough patience could download it and conduct their own analysis. Papers were published at an accelerating rate. Discoveries were announced regularly. The mission was hailed as one of the most successful scientific endeavours in history, and by most conventional metrics it absolutely was. But here's where the conspiracy begins to take shape. Why stare at one small section of sky for so long? The official answer is statistical reliability. To determine how common planets are, you need long-term, uninterrupted observation of a large sample of stars. A planet like Earth takes 365 days to orbit its star, so to confirm its existence, you need to see at least 3 transits. That means observing for at least 3 years minimum. 4 is better, 5 is ideal, and to establish meaningful statistics, you can't just watch a handful of stars. You need thousands, tens of thousands. The more stars you monitor, the more robust your conclusions. That explanation makes perfect sense. It's rational. It's scientifically sound. Mission planners would have made the same decision regardless of any hidden agenda. But there's another interpretation that fits the facts equally well. If you were conducting surveillance on a population, you wouldn't scan randomly. Random sampling introduces noise, makes pattern recognition harder, and limits your ability to track changes over time. Instead, you'd pick a representative sample and monitor it intensively. You'd watch the same group long enough to establish baseline behaviours, detect anomalies, and identify responses to stimuli. This is standard practice in intelligence work. It's how surveillance satellites operate. It's how signals intelligence is gathered. It's how populations are monitored without their knowledge. You don't watch everyone. You watch enough to understand everyone. Kepler's mission design mirrors this exactly. A fixed field of view, continuous observation, long-term data collection, population-level statistical analysis. These are the hallmarks of professional surveillance architecture. And if humanity was conducting that kind of observation on distant star systems, designing our instruments using principles refined through decades of intelligence gathering and monitoring, what's to say someone else wasn't doing the same to us? What's to say they hadn't been doing it far longer? There's a specific detail about Kepler's target field that rarely gets mentioned in public discussions. The region between Cygnus and Lyra wasn't chosen arbitrarily. It was selected because it lies outside the plane of the Milky Way's disk, meaning there's less dust and gas to interfere with observations. The view is cleaner. The signal-to-noise ratio is better. In other words, it's easier to watch. But here's the thing about choosing a clear line of sight. It works both ways. If we're looking at them through a relatively unobstructed window, they're looking at us through the same window. The region of space Kepler observed is roughly 3,000 light-years away at its furthest extent. That means the light Kepler detected left those stars 3,000 years ago during the time of ancient Egypt and early Chinese dynasties on Earth. If there's a civilization in that region with technology comparable to ours, and if they pointed a telescope toward our Sun 3,000 years ago, they would be seeing Earth as it was in roughly 1000 BCE. But if their technology is significantly more advanced than ours, if they developed space telescopes centuries or millennia before we did, they might have been watching Earth during the Roman Empire, the Renaissance, the Industrial Revolution. They might be watching us right now, and we would have no way of knowing. The light that carries information about Earth travels outward at the speed of light, as does the light carrying information about their worlds travelling toward us. We're both embedded in an expanding sphere of electromagnetic radiation, constantly broadcasting our presence to anyone with the instruments to detect it. Kepler was designed to detect Earth-sized planets at distances of hundreds or thousands of light-years. If our technology can do that now, imagine what a civilization even a few centuries ahead of us could detect. Biosignatures in atmospheric spectra, industrial pollutants, radio emissions, the heat signatures of cities. If they're out there, and if they've been watching, they know we're here. And Kepler's most important discovery might not have been finding their worlds. It might have been confirming that they could have found ours. Chapter 3. The First Shock. Within the first few years of operation, Kepler confirmed something that stunned even optimistic scientists. Earth-sized planets are common, not rare, not unusual, common. The first confirmed planet, designated Kepler 4b, was announced in January of 2010, less than a year after the mission began. It was a gas giant, not Earth-like, but it proved the detection method worked. The announcements came faster after that. In February 2011, the Kepler team announced the discovery of 1,200 candidate planets from the first 4 months of data alone. 1,200 from 4 months in one small patch of sky. The scientific community was reeling. By February 2012, the team confirmed that planets in the habitable zone, the region around a star where liquid water could exist, were found orbiting roughly 1 in 5 Sun-like stars. Some estimates, depending on how you define the habitable zone and which types of stars you included, went even higher. Some said 1 in 3, some said 1 in 2. Let those numbers sink in for a moment. In our galaxy alone, there are estimated to be somewhere between 100 billion and 400 billion stars. If even 1 in 5 has a planet in the habitable zone, that means tens of billions of potentially life-supporting worlds in the Milky Way alone. Tens of billions. And that's just one galaxy among trillions in the observable universe. William Burke, the mission's principal investigator, made a statement during a press conference that would echo through the scientific community for years. We used to think Earth-like planets might be rare. Now we know they're everywhere. His voice was steady when he said it, but there was something in his expression that people who watched the recording later commented on. A kind of weight. The look of someone who understands the implications of what they're saying extends far beyond the immediate data. Everywhere. The word hung in the air during that press conference. Journalists scribbled notes, cameras recorded, and somewhere in the audience someone asked the obvious follow-up question that everyone was thinking but few wanted to voice. If they're everywhere, where is everyone? Burke smiled slightly, the kind of smile that doesn't quite reach the eyes, and he said something interesting. That's a different mission. The room laughed. It was a good deflection. Professional, but it didn't answer the question. In the weeks and months that followed, the discoveries kept coming. Kepler 22b, the first confirmed planet in the habitable zone of a Sun-like star. Kepler 62e and Kepler 62f, both potentially rocky worlds in the habitable zone of a cooler star. Kepler 452b, the most Earth-like planet discovered by the mission, orbiting at a distance similar to Earth's orbit, around a star similar to our Sun. Each discovery was celebrated. Papers were published. Data was analysed and reanalysed. The architecture of these planetary systems was studied in detail, and quietly, beneath the celebration, a realisation was spreading through the scientific community. If life-supporting planets are this common, then life itself is probably common too. And if life is common, then intelligence, however rare it might be as a percentage, should still exist in significant numbers across the galaxy. The math was inescapable. There should be someone out there, many someones, civilizations that formed long before Earth did, that had millions or billions of years to develop technology, expand and make their presence known. The galaxy should be teeming with signals, megastructures, evidence of engineering on cosmic scales, but we detect nothing. No radio transmissions matching artificial patterns, no obvious signs of stellar engineering, no probes visiting our solar system, no attempts at communication, just silence. Within Kepler's narrow keyhole alone, thousands of potentially habitable worlds were identified. The mission catalogue eventually included over 4,000 candidate planets, with more than 2,700 confirmed through follow-up observations. The universe, it seemed, was teeming with places where life could exist. This should have been the greatest discovery in human history, and in many ways, it was celebrated as exactly that. NASA held press conferences, documentaries were made, the data was featured in textbooks and taught in classrooms. But it also introduced a profound problem that couldn't be solved with more data or better instruments. If the universe is full of places where life can exist, and if the conditions for life are as common as Kepler proved they are, then the absence of contact becomes exponentially more difficult to explain through random chance alone. You can't argue anymore that we're alone because Earth-like planets are rare. Kepler proved they're not rare. You can't argue that the conditions for life are so specific, so unlikely, that intelligence must be a cosmic fluke. The chemical building blocks of life are everywhere. Water is common. Energy sources are abundant. Time has not been the limiting factor. Every conventional explanation for the Great Silence became harder to defend, which left unconventional explanations. And one of those explanations, whispered in conference hallways and discussed in private emails between researchers, was simple and chilling. There, quiet because being loud is dangerous, or alternatively, they're quiet because they're watching. Chapter 4. The Silence That Followed. The Fermi Paradox, named after physicist Enrico Fermi, asks a deceptively simple question. If intelligent life is common in the universe, why haven't we detected any signs of it? The story goes that Fermi posed this question during a casual lunch conversation at Los Alamos National Laboratory in 1950. He and his colleagues were discussing flying saucers and the possibility of faster-than-light travel when Fermi suddenly asked, "Where is everybody?" It was meant as a light-hearted question, but it cut to the heart of a genuine scientific mystery. At the time Fermi asked it, we didn't know if planets existed around other stars. We didn't know if solar systems were common or rare. We couldn't say with any confidence whether Earth was typical or extraordinary. But even with that uncertainty, the math suggested we shouldn't be alone. The galaxy is old. It contains hundreds of billions of stars. Even if the odds of life arising are vanishingly small, the sheer number of opportunities should produce someone somewhere. And if even one civilization had developed interstellar travel millions of years ago, they should have had enough time to colonize the entire galaxy by now. Even travelling at a small fraction of light speed, a civilization could spread across the Milky Way in a few million years. That's nothing on cosmic timescales. So where are they? Before Kepler, you could construct plausible answers to that question. Maybe Earth-like planets are rarer than we think. Maybe the specific conditions needed for life to arise and develop into intelligence are so improbable that we truly are alone, or at least so isolated that contact is impossible. These weren't satisfying answers, but they were defensible. Kepler destroyed that defense. Habitable worlds are abundant. The building blocks of life are everywhere we look. The universe is old enough for civilizations to have risen, spread, built megastructures and colonized entire star systems thousands or millions of times over. And yet, we detect nothing. No radio signals matching intelligent design. No optical pulses. No infrared excess from Dyson spheres. No probes in our solar system. No signs of stellar engineering or large-scale construction. No artifacts on the Moon or Mars. Nothing. The SETI project, the search for extraterrestrial intelligence, has been scanning the skies for artificial signals since 1960. Over 60 years of searching. Billions of channels analysed. Thousands of stars surveyed. Silence. The Allen Telescope Array, the Green Bank Telescope, the Arecibo Observatory before its collapse, all of them listening, all of them finding nothing but the background whisper of the universe itself. After Kepler's discoveries, this silence became statistically bizarre. If habitable planets are common, and if even a small fraction of them develop life, and if even a tiny fraction of that life develops intelligence and technology, then we should be seeing something. Anything. The absence of evidence started to feel like evidence of something else entirely. Various explanations have been proposed over the years. Maybe intelligent life destroys itself before achieving interstellar travel. Maybe it's rare for civilizations to survive their own technological adolescence. Nuclear weapons, climate change, artificial intelligence gone wrong, engineered pandemics, pick your catastrophe. That's the Great Filter hypothesis. The idea is that there's some extraordinarily difficult step in the evolution from simple chemistry to interstellar civilization, and most species never make it past that filter. Maybe it's behind us. Maybe we've already passed the hardest part, and we're one of the lucky few. Or maybe it's ahead of us. Maybe every civilization reaches a point where it annihilates itself, and we just haven't gotten there yet. That's a dark thought, but it would explain the silence. Another explanation is that space is simply too vast. Even if civilizations exist, they might be so far apart that communication is impossible. Light takes years to cross even tiny cosmic distances. A signal sent to a star 10 light-years away won't get a response for 20 years minimum. And if civilizations only last a few thousand years before collapsing, the odds of two of them existing at the same time and being close enough to communicate become vanishingly small. That's the cosmic loneliness hypothesis. We're not alone, but we might as well be. Then there's the idea that we're simply looking in the wrong way. Maybe advanced civilizations don't use radio. Maybe they've moved beyond electromagnetic communication entirely. Maybe they're using technologies we can't even conceive of yet, and we're like tribesmen standing on a beach looking for smoke signals while satellite transmissions pass invisibly overhead. All of these explanations have merit. All of them have been seriously discussed by credible scientists. But after Kepler, another explanation started gaining traction in certain circles. Not in official papers or mainstream conferences, but in private conversations, forum posts and speculative discussions. The conspiracy interpretation of the Kepler syndrome hinges on this silence. It suggests that the quiet isn't evidence of absence, it's evidence of discretion. Advanced civilizations, the theory goes, don't announce themselves. They don't broadcast. They don't build megastructures that scream, "We are here," to anyone watching. They observe, they catalogue, they wait. And the reason we haven't heard from them isn't because they don't exist. It's because announcing yourself in a dark forest is a good way to get shot. That's Liu Cixin's dark forest hypothesis, laid out in his science fiction trilogy. The idea is that the universe is full of civilizations, but they all stay hidden because revealing yourself means risking annihilation by someone bigger, older, and more dangerous. Broadcast your presence, and you might attract predators. Stay quiet, and you might survive. It's a paranoid vision of the cosmos, but it explains the silence perfectly. Everyone's out there, but everyone's hiding. But there's another version of this idea that's less about fear and more about protocol. What if advanced civilizations don't announce themselves because doing so would contaminate the natural development of younger species? What if there are rules? What if we're being watched, not out of hostility or indifference, but as subjects in the most important experiment in the galaxy, the natural evolution of intelligence? And if that's true, then the silence isn't empty. It's full of observers, patiently taking notes. Chapter 5. The pattern in the data. In the years following Kepler's initial discoveries, independent researchers began noticing something unusual in the data. Not wrong exactly, not contradicting the official findings, just unexpected. The distribution of planets wasn't random. This realization emerged slowly, spread across multiple papers and forum discussions. No single researcher can claim credit for noticing it first, but by 2014 or so, the pattern had become clear enough that people started talking about it openly. Certain star systems displayed what some called architectural stability. Planets in these systems had nearly circular orbits, minimal eccentricity, low inclination angles. Their spacing followed mathematical ratios that reduced gravitational interference between planets, making the entire system more stable over long timescales. In technical terms, these systems exhibited what astronomers call resonant chains, planets locked into orbital periods that related to each other through simple ratios, 2:1, 3:2, 5:3. When planets settle into these resonances naturally, it's usually through a process called migration, where gravitational interactions over millions of years slowly adjust orbits until they reach stable configurations. It happens, it's documented, it's not controversial. But the frequency at which Kepler detected these resonant systems was higher than models predicted, significantly higher. A paper published in 2016 analysed the orbital architectures of multi-planet systems detected by Kepler. The authors found that planets in these systems were spaced, on average, more regularly than random formation processes should produce. The official explanation for this pattern is selection bias. Kepler was better at detecting certain types of planetary systems because of how the transit method works. Systems aligned edge-on to our perspective, with planets in stable, coplanar orbits, were simply easier to spot. Systems with chaotic orbits or high inclination angles would produce irregular transit, patterns that might not be recognised as planets at all. That's a valid point. It's scientifically defensible. Selection bias is a real problem in observational astronomy, and accounting for it is standard practice. But it's also true that if you were in advanced civilization engineering stable environments for long-term habitability, this is exactly what the result would look like. managed systems, curated orbits, planets positioned to maximize stability and minimize catastrophic interactions. The conspiracy doesn't claim these systems are artificial, it claims they're maintained. There's a difference. Let me give you a specific example that illustrates this point. In 2014, Kepler detected a system designated Kepler 385. It contains 5 planets, all in nearly circular orbits, all aligned in almost the same plane. The orbital periods follow a resonant chain. Each planet's year is related to its neighbours through simple mathematical ratios. The system is incredibly stable. Computer simulations suggest it could remain in this configuration for billions of years without any planets being ejected or colliding. Now, systems like this can form naturally. Migration and gravitational interactions can produce resonant chains. It happens around other stars. It's happened in our own solar system in the past. But here's the interesting part. Kepler 385 is far more stable than it needs to be. Most resonant chains are metastable. They last for a long time, but eventually perturbations from distant stars or passing objects will disrupt them. Orbits shift. Resonances break. The system evolves. But Kepler 385 shows no signs of that kind of evolution. It's locked in. Perfect. Almost too perfect. A researcher posting on an astronomy forum under the username Echo Survey put it this way. Natural systems tend toward maximum entropy over time. They degrade. They become less organised. Kepler 385 looks like someone hit pause on entropy. That post was made in February 2015. It received 34 replies in the first hour. By the next morning, the thread had been locked by moderators with a note saying discussion has become too speculative. The user Echo Survey never posted again. Another example, Kepler 90. This system has 7 confirmed planets, and possibly an 8th. The planets range from roughly Earth-size to slightly larger than Jupiter. And here's the remarkable part. All 7 confirmed planets have well-defined orbits with very low eccentricity, and they follow a resonant structure that keeps them from interacting chaotically. The system is so stable that researchers use it as a test case for orbital dynamic simulations. It's a textbook example of how planets can coexist in a small region of space without destroying each other. But it's also statistically improbable that such a stable configuration would arise, naturally, and remain stable for the age of the system, which is estimated at roughly 2 billion years. One astronomer, speaking anonymously at a conference in 2017, said something interesting during a panel discussion. The comment wasn't included in the official proceedings, but people who were there remember it. He said, "We're finding what we'd engineer if we could. That either means nature is better at engineering than we thought, or someone else is doing the engineering." The room went quiet. The moderator moved to the next question. The subject wasn't brought up again. The pattern shows up in other ways too. Kepler detected multiple systems with planets in the habitable zone that have almost no orbital eccentricity. Perfectly circular orbits. This is significant because orbital eccentricity affects climate stability. A planet with a highly elliptical orbit will experience extreme seasonal variations as it swings closer to and farther from its star. Life, especially complex life, has a harder time developing in those conditions. Circular orbits provide stable climates, predictable seasons, conditions that favour the long-term evolution of ecosystems, and Kepler found them everywhere. The official line is that this is, again, selection bias. Planets in circular orbits are easier to detect because their transits are regular and predictable. Planets in elliptical orbits produce irregular signals that might be filtered out as noise. But there's another interpretation. If you were a civilization capable of manipulating planetary orbits, or if you were selecting which systems to seed with life, or if you were simply identifying which systems to monitor because they're most likely to produce interesting results, you'd focus on systems with stable circular orbits. You'd focus on the places where life has the best chance of surviving, long enough to become complex. You'd focus on places like Earth. And if that's what's happening, if there's a selection process operating at a galactic scale, then Kepler didn't just discover that habitable planets are common. It discovered that habitable planets are where the watchers are looking. Chapter 6. Observation without interaction. The core premise of the Kepler syndrome is this: advanced civilizations do not make contact, they observe. This idea isn't new. It appears in science fiction, philosophy, and even formal scientific discussions. But Kepler gave it a framework. Consider how humanity approaches ecosystems we want to study. When biologists observe endangered species, they don't approach the animals directly. They set up cameras. They track movements from a distance. They minimize interference to preserve natural behavior. When anthropologists study isolated tribes, ethical guidelines prohibit direct contact. Observation is conducted remotely. Interaction is avoided. The reasoning is simple. Contact changes the subject. Once you intervene, you're no longer studying the system as it naturally exists. You're studying your impact on it. Now scale that principle to a cosmic level. If an advanced civilization wanted to understand how intelligence emerges, how societies develop, how technology evolves, the worst thing they could do is reveal themselves. Their presence would distort everything. So they watch, they catalogue, they wait. And if Earth is part of that catalogue, if we're one data point among billions, then the Kepler mission didn't discover extraterrestrial life. It discovered that we were already discovered. Chapter 7. Earth as a known quantity. Here's the uncomfortable part of the theory. If habitable planets are common, and if observation is the preferred method of study, then Earth is almost certainly being monitored. Not because we're special, because we're typical. We're a standard model terrestrial planet orbiting a standard model star in a standard model galaxy. We have liquid water, a stable climate, and complex life. By cosmic standards, we're exactly the kind of system that would be worth watching. And if someone is watching, they've been watching for a long time. Long before Kepler launched. Long before we developed radio. Long before we understood what planets even were. The theory suggests that Earth is indexed, catalogued, known, not as a target, as a sample. And Kepler, in its mission to find other worlds, inadvertently revealed the methodology by which we ourselves might have been found. Discovery, the conspiracy argues, works both ways. We built a telescope to search for them, but if they're more advanced, they built theirs first. And when we finally looked out into the universe with Kepler, we weren't discovering new worlds. We were joining a network of observation that had been operating long before we arrived. Chapter 8. The unspoken rule of non-interference. In scientific and philosophical circles, there's a concept called the zoo hypothesis. It was first proposed by radio astronomer John Ball in 1973, decades before Kepler launched. He presented it at a meeting of the International Astronomical Union, and the paper was later published in a journal called Icarus. The idea is simple but profound. Extraterrestrial intelligence exists but deliberately avoids contact with humanity to allow for natural evolution and development. We're not alone. We're quarantined. Ball's reasoning was straightforward. If intelligence is common in the universe, and if even one civilization had developed interstellar travel millions of years ago, they should have colonized the entire galaxy by now. The fact that we see no evidence of colonization, no signs of galactic engineering, no obvious alien presence, doesn't necessarily mean they don't exist. It might mean they're choosing not to be seen. The analogy Ball used was deliberate. We create nature preserves and protected zones where human interference is minimized. We establish wildlife, sanctuaries where animals can develop without direct human contact. We've even debated how to approach uncontacted tribes on Earth, with most anthropologists agreeing that observation without interference is the ethical approach. If we, a relatively young technological civilization, understand the value of non-interference, why wouldn't more advanced civilizations apply the same principle to us? The zoo hypothesis suggests that contact will only occur after a civilization crosses certain thresholds. The exact criteria are debated, but common suggestions include developmental milestones that indicate a species is ready for broader contact, nuclear capability, spaceflight beyond the home planet, artificial intelligence, detection of other civilizations, unified planetary governance, post-scarcity economics, mature ethical frameworks. Notice something. We've crossed several of those already. We developed nuclear weapons in 1945. We've sent humans to the moon and robots to Mars, Venus and beyond. Artificial intelligence is accelerating faster than most predicted. And Kepler proved that we're actively searching for others, that we understand we might not be alone. But we haven't achieved the others. We're still politically fragmented. Resource scarcity drives much of our conflict. Our ethical frameworks are evolving but far from mature. Maybe we're close to the threshold. Maybe we're right at the edge. Or maybe the threshold isn't a checklist of achievements. Maybe it's something more fundamental. Maybe the threshold is recognition. The moment a civilization realizes it might be being observed is the moment the quarantine becomes voluntary. They're no longer isolated by ignorance. They're isolated by choice, by caution, by the understanding that the universe might be full of others who are also being careful. This is where the Kepler syndrome intersects with the zoo hypothesis, in a profound way. Kepler's mission revealed that habitable worlds are everywhere. It demonstrated that the conditions for life are common, abundant and widespread. And in doing so, it forced humanity to confront a question we'd been avoiding. If the universe is full of places where life can exist, and if we're looking for them, what does it mean that they haven't been looking for us? Or rather, what does it mean if they have been, and we're just now noticing? The zoo hypothesis has been criticised over the years. Some scientists argue it's unfalsifiable, that it can explain any observation by simply adding more layers of hidden watchers. Others say it assumes all civilizations would follow the same ethical framework, which seems unlikely given how diverse human cultures are on a single planet. But the criticism that cuts deepest is this. The zoo hypothesis requires coordination. If even one civilization in the galaxy decided to make contact, the quarantine would break. You can't maintain a zoo if one of the zookeepers starts talking to the animals, unless of course there are consequences for breaking the rules. That's where the dark forest hypothesis comes back in. Maybe civilizations don't announce themselves not just out of caution, but out of enforcement. Maybe there are watchers watching the watchers, ensuring that younger civilizations are allowed to develop naturally. Maybe the silence isn't maintained by choice alone. Maybe it's maintained by pressure. The Kepler syndrome suggests something even more unsettling. What if the threshold for contact isn't about our capabilities at all? What if it's about our awareness? What if advanced civilizations wait until younger species realize they're being observed before revealing themselves because that realization is itself a test? How you react to the possibility of observation says a lot about who you are as a civilization. Do you become paranoid? Do you lash out? Do you retreat into isolation? Or do you keep growing, keep exploring, keep developing, even knowing you might be watched? That reaction might be the real threshold. And if Kepler's mission was designed, intentionally or not, to trigger that realization, then we're living through the test right now. Every choice we make as a species, every decision about how we approach the cosmos is being recorded, not for judgment, for evaluation. And when the watchers decide we're ready, assuming we pass whatever criteria they're using, contact won't come as a surprise. It'll come as a confirmation of what we already suspected. If the zoo hypothesis is correct, and if there are thresholds for contact, we may be approaching them. But here's the critical point. Even if we've crossed the line, disclosure might not come from them. It might come from us realizing we were never hidden. The Kepler syndrome suggests that contact isn't an event, it's a recognition. The moment a civilization understands it's being observed is the moment the quarantine ends, and maybe, just maybe, that's what Kepler's data was designed to trigger. Chapter 9. Why disclosure would never happen. Let's assume for a moment that the Kepler syndrome is real. Let's say Earth is being observed by an advanced civilization. Let's say this has been confirmed by classified analysis of Kepler's data. Let's say a small group of scientists and officials knows this to be true. Would they tell us? The answer is no. And not because of malice or conspiracy in the traditional sense. It's because of consequence. Think about what disclosure would actually mean. If humanity learned definitively that we are being watched by an intelligence beyond our comprehension, the psychological, social and political impacts would be immediate and catastrophic. Start with religion. Every major faith on earth places humanity in a specific cosmic context. We're made in God's image. We're the chosen people. We're central to creation. These aren't just theological claims, they're foundational to billions of people's understanding of meaning, purpose and morality. If we learn that we're specimens in someone else's observation project, that context collapses. Are we still special if there are millions of other observed worlds? Are we still chosen if the Watchers have been studying civilizations for eons before we existed? Are we still central to creation if we're one data point in a cosmic census? Some believers would adapt. They'd integrate the new information into their worldview. God works through the Watchers. The Watchers are angels. The observation is divine will. But many wouldn't adapt. They'd fracture. Faith communities would split. New interpretations would compete with old ones. The social cohesion that religion provides would crack under the weight of cosmic insignificance. And that's just religion. Geopolitics would destabilize even faster. National sovereignty is built on the idea that nations are the highest level of political organisation. They make laws, wage wars, control resources and maintain order within their borders. The entire international system is predicated on this framework. If we're all subjects in someone else's study, that framework becomes absurd. What does it mean to have borders if we're all inside a larger boundary we can't see? What does it mean to wage war if every conflict is being recorded and analysed by observers who could intervene but choose not to? What does defence spending mean if the real power in the galaxy is so far beyond us that our militaries are irrelevant? The psychological impact on national identity would be profound. People derive meaning from belonging to something larger than themselves, their country, their culture, their history. But if all of that is being watched, catalogued and compared to millions of other civilizations, does it still matter? The answer might be yes, it might be no. But the question alone would be enough to cause paralysis. Leaders who base their authority on nationalistic narratives would see that authority crumble. International alliances would shift as countries try to position themselves for whatever comes next. The entire system of global governance, already fragile, would be thrown into chaos. And then there's science. The scientific method is built on the assumption that we're discovering truth through observation and experimentation. We test hypotheses, we collect data, we build models that explain the universe. But what if some of those discoveries weren't discoveries at all? What if they were allowed? This is the most insidious aspect of the disclosure problem. If Earth has been observed for a long time, and if the observers have technology far beyond ours, then they could have influenced our development in subtle ways without us knowing. Not direct intervention, but gentle nudges, allowing certain discoveries to happen, preventing others. Think about every major scientific breakthrough in history. The discovery of fire, the invention of agriculture, the development of writing, the scientific revolution, the industrial revolution, the nuclear age, the space age, the digital revolution. Were those achievements purely the result of human ingenuity, or were they milestones that the observers wanted us to reach, and so they ensured that the conditions for discovery were in place? You can't prove it either way. That's the problem. Once you introduce the possibility of outside observation, every achievement becomes suspect. Not obviously controlled, but potentially influenced. And that uncertainty erodes the foundation of scientific authority. If scientists can't be sure that their discoveries are truly theirs, why should the public trust them? The framework of meaning that holds civilization together would shatter. And here's the critical part. This wouldn't be a temporary disruption. This would be a permanent shift in how humanity understands itself. We've faced existential challenges before, wars, plagues, natural disasters, but we've always recovered because the fundamental framework remained intact. We were still the primary actors in our own story. Learning that we're being observed changes that. Permanently. We're no longer the protagonists, we're subjects. And once you see yourself that way, you can't unsee it. And so, the conspiracy argues, silence isn't secrecy in the way we usually think of it. It's containment. The people who know, assuming they exist, don't hide the truth to control us. They don't keep secrets to maintain power. They hide it to preserve the psychological and social structures that keep civilization functioning. They hide it because some revelations don't liberate, they erase. They hide it because humanity isn't ready for the truth, not because we can't handle it intellectually, but because we can't handle it socially. And maybe they're right. Maybe the revelation that we're being observed should come slowly, through inference rather than announcement, through gradual realization rather than sudden disclosure. Maybe that's why Kepler's data was released publicly, not to hide the truth, but to let us find it ourselves, at our own pace, in a way that doesn't shatter everything we've built. The Kepler syndrome isn't about a government cover-up. It's about a slow, managed awakening. And if that's true, then we're in the middle of it right now. Chapter 10. The End of the Mission. In October of 2018, NASA announced that Kepler had run out of fuel. The telescope, after over 9 years of continuous operation, was retired. It drifted silently in space, its mission complete. Officially, Kepler had discovered over 2,700 confirmed exoplanets. It had revolutionized our understanding of planetary formation. It had proven that worlds like Earth are common. The mission was declared a triumph. But here's the thing about surveillance systems. Once you've established observation, you don't need the same tools anymore. If Kepler's real purpose was to confirm that Earth-like planets are everywhere, and if that confirmation revealed that we are likely being observed, then the telescope itself becomes redundant. The data exists, the implications exist, the knowledge exists. Kepler's end wasn't a loss, it was a milestone, and if other civilizations have been watching us the entire time, they didn't need Kepler to keep tabs on Earth. They already had their own instruments pointed our way. The conspiracy interpretation is chilling in its simplicity. Kepler was never about finding them. It was about realizing they'd already found us. And once that realization occurred, once the data made it undeniable, the mission's real purpose was complete. The telescope could be shut down. The observation, however, continues. Epilogue. The feeling that never left. There's a sensation that comes with learning you're being watched. It's subtle at first, a prickling awareness, a sense that the space around you isn't as empty as it seems. You can't point to a specific moment when it began. You can't prove it, but you feel it. And once you feel it, you can't unfeel it. That's what Kepler left behind. Not proof, not evidence, not disclosure, just the feeling. The mission taught us that planets like Earth are everywhere. It taught us that the universe is full of places where life could exist. It taught us that the building blocks of biology are common, abundant and ancient. But it also taught us something else. In a cosmos crowded with potential observers, silence is not the same as solitude. The quiet we experience when we look at the stars and hear nothing back might not mean we are alone. It might mean we are being allowed to grow. And if that's true, if Earth is one world among billions under observation, then every choice we make, every step we take as a species, is being recorded. Not judged, not interfered with, just recorded. The Kepler syndrome doesn't claim that aliens are coming. It doesn't predict invasion or contact. It simply suggests that we were never as hidden as we thought. And the moment we built a telescope to look for others, we joined a game that was already in progress. Somewhere out there, in a star system Kepler might have catalogued, another civilization might be doing the same thing we are, building instruments, scanning the skies, searching for signs of life. And when they point their telescopes toward our corner of the galaxy, when they detect the faint dimming of our sun as Earth passes in front of it, they won't be discovering us. They'll be confirming what was always known. We're here, we're watching, and so are they. That's the Kepler syndrome. Not a conspiracy of secrecy, a conspiracy of mutual observation, and once you see it, you can't look at the night sky the same way again. Because the stars aren't just distant suns anymore. They're windows, and something somewhere is looking back, is Hey everyone, before we dive into tonight's story, I want to ask for your help in supporting the channel. If you're enjoying this content, please use your hype points on this video. It genuinely helps more than you could possibly know and makes a massive difference in getting these stories out to more people. If you're listening over on Spotify, leaving a review would mean the world to us. And if you feel like it, drop a comment letting us know what time it is where you are and where in the world you're tuning in from. We absolutely love seeing where everyone is listening. It's incredible to know this community spans the globe. And of course, if you're enjoying the content and haven't already, please consider subscribing. It helps us keep creating these stories for you. Alright, let's get into it. It started with static, not the harsh crackle of a dying signal, but the soft hiss of late-night AM radio, bleeding through the darkness of a bedroom in suburban Ohio. The year was sometime in the late 1990s, back when the internet was still dial-up and the night belonged to voices travelling through electromagnetic waves. Marcus Webb lay in bed, half awake, listening to Coast to Coast AM with Art Bell. He'd stumbled onto the show by accident weeks earlier while scanning through frequencies, looking for something to fill the insomnia hours. What he found was a world of paranormal discussion, conspiracy theories, and callers sharing experiences that existed somewhere between the documented and the impossible. This particular night, a caller from Arizona was describing something that would fundamentally alter how Marcus understood the boundary between known and unknown. The voice was male, middle-aged, steady. Not the excited rambling of someone seeking attention, but the measured tone of someone trying to make sense of something that defied explanation. He described driving home from a late shift at a manufacturing plant, taking the same route he had driven for 7 years. The highway stretched through flat desert terrain, unremarkable and familiar. Then he saw it, a massive triangular craft hanging motionless above the road, approximately a quarter-mile ahead. 3 dim lights positioned at each corner, amber in colour, not bright but clearly visible against the night sky. The craft was enormous. The caller estimated the size of a football field, though he admitted distance and darkness made precise measurement impossible. What struck him most was the silence. Complete and absolute silence. He slowed his vehicle, pulled to the shoulder, and watched. The craft remained stationary for what he estimated as 5 minutes, though time felt distorted. Then, without warning, it moved. Not the acceleration of conventional aircraft, but a smooth, deliberate glide that seemed to ignore physics as he understood them. It passed directly overhead, close enough that he could make out a dark surface texture, completely blocking out the stars above. Art Bell, in his characteristically calm manner, asked the question that needed asking. "And you're absolutely certain this wasn't a conventional aircraft? A cargo plane, perhaps? Or military transport?" The caller's response carried a quiet certainty that Marcus would never forget. Planes don't move like this. Planes make noise. Planes have navigation lights that blink. This thing was silent. Completely silent. And those lights didn't blink once. And the way it moved, it was like it was being pulled by something, not propelled. The segment lasted maybe 8 minutes. Art thanked the caller, took another, and moved on to different topics. But for Marcus, something had changed. The description lodged itself in his mind with uncomfortable persistence. Not because it was dramatic or terrifying, but because it was specific. Details that rang with authenticity. A witness who sounded genuinely confused rather than convinced. He couldn't explain why, but he knew he would be listening more carefully from that night forward. Chapter 1. The pattern in the calls. Over the following weeks, Marcus developed a ritual. He would finish his shift at the bookstore where he worked, drive home, and tune in to Coast AM, listening through the night until sleep finally claimed him, or dawn broke, whichever came first. And he began noticing something. The black triangles kept appearing in caller testimonies. Not every night, but regularly enough to establish a pattern. A woman from Nevada describing the same shape hovering over her rural property. A retired police officer from Illinois recounting a sighting during a routine patrol. a college student from Texas who witnessed the craft while driving home from a late study session. The details were remarkably consistent. Triangular shape, always equilateral or nearly so. 3 lights at the corners, typically amber or red, occasionally white. Size estimates varied from large to absolutely massive. Movement that defied conventional aerodynamics, hovering motionless or gliding smoothly at low speeds. And always, that defining characteristic, absolute silence. What struck Marcus most wasn't the similarity of the descriptions, though that was significant. It was the tone of the callers. These weren't people excited about seeing something extraordinary. They weren't seeking validation or attention. They sounded genuinely confused, sometimes disturbed, as if the experience had violated their understanding of how the world worked. A caller from Oregon, a software engineer named Thomas, described his sighting with technical precision. He had been walking his dog late one evening when he noticed the stars being blocked out in a triangular pattern. Looking up, he saw the craft hovering perhaps 300 feet above the neighbourhood. He estimated he watched it for 12 minutes. He noted the lack of air displacement, the absence of any heat signature visible to the naked eye, and the unsettling realization that something that large should have been generating some kind of atmospheric disturbance. "I kept waiting for the sound to hit," Thomas said. "Like when you see lightning before you hear thunder. I thought maybe the sound just hadn't reached me yet, but it never came. That thing was right there, and it made no sound at all." Another caller, an elderly woman from Florida named Patricia, described waking at 3 a.m. to find her bedroom illuminated by amber light. Looking through her window, she saw a triangular craft hovering directly above her house, low enough that she could make out panel seams on the underside. She watched for approximately 20 minutes before it slowly drifted away, moving south toward the Gulf Coast. "I wasn't frightened," she said. "I don't know why. I should have been terrified, but I just felt calm. Like whatever it wasn't interested in me. I was just there, and so was it." The sightings spanned geography with no apparent pattern, urban areas, rural communities, coastlines, mountains, deserts. The United States saw the majority of reports, but international callers began sharing similar experiences. Someone from the United Kingdom describing a sighting near a military installation. A caller from rural France recounting an encounter while driving through countryside late at night. Marcus started keeping notes. Not organised research exactly, just a spiral notebook where he jotted down details. Dates when possible, though many callers didn't provide them. Locations, descriptions, the small details that repeated across testimonies. He noticed something else too. These witnesses didn't sound like they had been comparing notes. They didn't use the same phrases or reference each other's sightings. Each account felt independent, isolated, personal, yet the descriptions aligned with uncomfortable precision. Chapter 2. The Belgium Wave. Marcus's casual interest evolved into something more systematic when he stumbled across a reference he couldn't ignore. A caller mentioned Belgium, specifically the Belgian UFO wave of the late 1980s to early 1990s. The caller suggested that anyone interested in triangular craft should research what happened there, because it was the most thoroughly documented mass sighting event in modern history. Marcus spent his next day off at the public library. What he found was extraordinary, not because it was sensational, but because it was official. This wasn't fringe testimony or anonymous reports. This was documented, investigated, and acknowledged by legitimate authorities. The Belgian UFO wave began in late November of 1989 and continued intermittently for several years. Thousands of witnesses across Belgium reported seeing large triangular craft, often hovering at low altitude over populated areas. The descriptions matched what Marcus had been hearing on Coast to Coast with: disturbing accuracy, dark triangular shapes, lights at the corners, silent movement, hovering capability. But Belgium went further. The Belgian Air Force took the reports seriously enough to scramble F-16 fighter jets on multiple occasions. Military radar installations tracked unidentified objects displaying flight characteristics that exceeded known aircraft capabilities. Speed, acceleration, altitude changes that shouldn't have been possible. On one notable night in late March of 1990, multiple radar installations tracked an object for over an hour. The craft was detected moving at speeds ranging from hovering to extreme velocity, making 90-degree turns that would have destroyed any conventional aircraft through G-force alone. F-16s were scrambled. Pilots achieved radar lock multiple times. Each time the object would suddenly drop in altitude or accelerate beyond the fighter's capability to follow. The Belgian government never claimed to have identified the objects. They acknowledged the sightings, confirmed the radar data, and stated openly that the objects displayed flight characteristics beyond known technology. Then they simply stopped discussing it. Marcus found transcripts of press conferences where Belgian Air Force officers described the events with professional restraint. They didn't speculate about alien origin. They didn't claim secret military testing. They just presented the data and admitted they had no explanation. What unsettled Marcus most was the credibility of the witnesses. Police officers, military personnel, commercial pilots, ordinary citizens, all describing the same phenomena. The Belgian Society for the Study of Space Phenomena, known as SOBEPS, conducted extensive investigations, collecting thousands of reports and photographic evidence. This wasn't folklore or urban legend. This was mass observation of something unexplained, happening in a NATO member country with sophisticated air defence systems and professional military oversight, and the objects matched the descriptions from Art Bell's callers with unnerving precision. Chapter 3. The Silence Factor. Marcus became fixated on one particular detail that appeared in virtually every credible report: the silence. Not just quiet, not just reduced engine noise, absolute, complete silence. He started researching aviation and physics, trying to understand why this detail mattered so much. What he learned made the black triangle reports even more inexplicable. Any object moving through atmosphere creates sound. The physical displacement of air generates noise. A conventional aircraft generates multiple sources of sound. Engines, air flowing over surfaces, control surface movements, the simple friction of a large object pushing through air at speed. Even gliders, which have no engines, create sound. The rush of air over wings, the displacement of atmosphere, the subtle whistle and hum of aerodynamic surfaces. Anyone who has been near a landing glider can attest to this. Helicopters are even louder, the rotor blades creating massive air displacement and characteristic thumping sounds, audible for miles. So how could a craft the size of a football field, hovering at low altitude or moving slowly through atmosphere, produce no sound whatsoever? Marcus found a forum where aviation enthusiasts and engineers discussed unexplained phenomena. He posed the question carefully, not mentioning UFOs, just asking theoretically, could an aircraft achieve silent flight at low altitude? The responses were consistent. No, not with any known technology. Stealth aircraft are designed to minimize radar signature, not sound. They still produce substantial noise. High-altitude aircraft generate less audible noise to ground observers simply because of distance, but at low altitude the sound would be unmistakable. One aerospace engineer provided a detailed explanation of why silence was particularly impossible for hovering. Craft. To counteract gravity, an aircraft must generate thrust downward, either through engines or rotor displacement. That thrust has to move air, and moving air creates sound. It's basic physics. You cannot generate enough force to hold a massive object aloft without creating detectable noise. Yet the reports continued describing exactly that. Massive craft, hovering motionless at low altitude, producing no sound. Marcus began cataloguing the specific descriptions of silence in the reports. Witnesses used phrases that went beyond simply quiet or no engine noise. They described an almost oppressive silence, a deadening of ambient sound, as if the craft itself absorbed noise from the surrounding environment. A caller from rural Montana described watching a triangular craft hover above a grove of trees. He specifically noted that even the usual night sounds, The insects and distant animal calls seemed muted while the craft was present. When it finally departed the normal soundscape, gradually returned. Another witness, a truck driver from Pennsylvania, reported that his diesel engine seemed quieter when the craft passed overhead, though his instruments showed the engine running normally. These details suggested something beyond mere silent propulsion. They hinted at some kind of field effect, something that affected sound itself in the vicinity of the craft. Chapter 4. The Government That Wouldn't Answer. As Marcus deepened his research, he expected to find aggressive government denial, a classic pattern of official debunking, ridicule and dismissal. What he found instead was more subtle and in some ways more disturbing. Official responses to Black Triangle sightings followed a pattern of deflection rather than outright denial. When witnesses reported sightings to authorities, they typically received one of several standard responses: misidentified conventional aircraft, atmospheric phenomena creating unusual light patterns, experimental military programs that couldn't be discussed, weather balloons, though that explanation had become something of a joke even among officials who used it. But what the official responses never did was aggressively attack the credibility of witnesses or launch campaigns to prove the sightings false. Instead, they offered plausible-sounding alternative explanations and then simply moved on. Marcus found this approach more effective than ridicule would have been. Ridicule creates martyrs and feeds conspiracy theories. Casual deflection suggests the matter isn't important enough to warrant serious attention. Yet inconsistencies existed in the official explanations. Conventional aircraft couldn't explain the hovering capability or silent operation. Atmospheric phenomena didn't account for solid objects tracked on radar. Experimental military programs would presumably be tested over restricted airspace, not civilian population centres. The Belgian government's response was particularly interesting. They acknowledged the sightings, confirmed the radar data, deployed military assets to investigate, and then essentially shrugged. No dramatic conclusions, no definitive explanations, just a professional acknowledgement that something unexplained had occurred, and they had no further information to provide. Marcus found several instances where military personnel or aviation professionals had reported Black Triangle sightings through official channels, only to receive responses that essentially ended the conversation. Acknowledge the report, file it appropriately, take no further action. A retired air traffic controller Marcus corresponded with via email described tracking an unknown object on radar that matched Black Triangle characteristics: slow movement, hovering capability, sudden acceleration. He filed a report as required. The response came back weeks later. Object could not be identified. No further investigation warranted. That phrase appeared repeatedly in official documentation Marcus managed to locate. No further investigation warranted. Not explained as conventional aircraft. Not determined to be misidentification. Simply acknowledged and filed away. Freedom of Information Act requests yielded heavily redacted documents that confirmed sightings had been reported and logged, but revealed almost nothing about how they were investigated or explained. The pattern suggested something more sophisticated than cover-up. It suggested controlled information management. Acknowledge enough to avoid appearing dismissive. Provide just enough explanation to satisfy casual inquiry. Then allow the matter to fade from attention. Chapter 5. The Military Theory. The most common explanation for Black Triangle sightings, particularly among those who accepted the reports as genuine, was secret military aircraft. Marcus spent considerable time exploring this possibility. The logic seemed sound initially. The military develops advanced aircraft in classified programs. These programs often remain secret for years or even decades. The triangular shape could represent some advanced design optimized for stealth or unconventional propulsion. Programs like the stealth bomber, the F-17 Nighthawk and other classified aircraft had been successfully kept secret during development. Perhaps the Black Triangles represented the next generation of such technology. Marcus researched known black budget programs and the history of classified aircraft development. The United States military-industrial complex certainly had the resources and motivation to develop revolutionary aircraft. Compartmentalized security meant that most people involved in such programs would know only their specific piece, maintaining operational security. But the timeline didn't support this explanation adequately. Black Triangle sightings dated back to at least the 1980s, possibly earlier. If these were experimental aircraft, from that era they would likely have been declassified or deployed operationally by now. The pattern of military technology suggests a development to deployment cycle measured in years, not decades of continued secrecy. Additionally, the flight characteristics reported for black triangles exceeded anything that had subsequently appeared in acknowledged military aviation. If the United States or any other nation had developed anti-gravity propulsion or silent hovering technology in the 1980s, why hadn't that revolutionary capability appeared in deployed systems? The geography of sightings also posed problems for the military explanation. Black triangles were reported over civilian areas worldwide, including countries with no access to American black budget technology. With the Belgians seeing American secret aircraft, why would the United States test revolutionary craft over allied nations without coordination? The Belgian government's response suggested they were as confused as the civilian witnesses. Marcus contacted several retired military personnel through online forums, carefully framing his questions to avoid sounding conspiratorial. The responses varied, but a pattern emerged. Some suggested classified programs but couldn't provide specifics. Others expressed skepticism that such revolutionary technology could be developed and tested without any operational deployment decades later. A few acknowledged they had heard persistent rumours about exotic aircraft programs, but had never seen evidence of operational deployment. One former Pentagon analyst made an observation that Marcus found compelling. If we had anti-gravity in the 80s, we wouldn't still be using conventional rockets and jets now. The technology would have revolutionised everything. You can't sit on something that transformative for 40 years without it leaking into other applications. The military explanation remained possible, but it required accepting that some nation had developed physics, defined technology decades ago and never deployed it, never allowed it to influence civilian aerospace development, and maintained perfect secrecy across multiple countries and thousands of witnesses. Chapter 6. The Art Bell connection deepens. Marcus continued his late-night listening ritual, and over time he began noticing something that added another layer of strangeness to the phenomenon. Callers who discussed black triangles on coast to coast sometimes reported subsequent encounters. Not immediately, and not in a way that suggested deliberate targeting, but frequently enough to form a pattern. Someone would call in describing a sighting from months or years earlier. Weeks later they might call back reporting another encounter. The timing felt too consistent to be coincidental. A caller named Richard from Idaho described seeing a black triangle while camping in the summer of 1996. He discussed the experience on air, noting specific details about the craft's movement and appearance. 3 months later he called back. He had seen it again, this time near his home, hovering above the tree line behind his property. Another caller, Jennifer from New Mexico, shared a sighting from early 1998. 2 months after her call, she reported another encounter, this one closer and longer in duration than the first. What disturbed Marcus most was a recurring phrase that appeared across these follow-up calls. I wasn't looking for it. Witnesses would emphasise that they weren't actively seeking another sighting. They weren't skywatching or investigating UFO hotspots. They were simply going about normal activities when the craft appeared again, often in locations or situations that seemed deliberately positioned for observation. One caller described it perfectly. It's like once you see them, they know you can see them, and then they show up again, like they're checking in on you. Art Bell ever. The thoughtful host would sometimes gently probe this aspect, asking callers if they felt the encounters were random, or if there seemed to be some kind of pattern or intention behind repeated sightings. The answers varied, but many callers expressed a gut feeling that the encounters weren't random, not necessarily threatening, but purposeful, as if being seen by these craft was itself meaningful in some way. Marcus began forming a hypothesis that unsettled him. What if the craft weren't hiding at all? What if their apparent visibility to certain witnesses was intentional? The stealth technology clearly existed, given the silent operation and the presumed radar-evading capabilities when desired. If these objects wanted to remain completely hidden, surely they could. So why allow themselves to be seen? Why hover over populated areas, knowing witnesses would observe and report? Why maintain positions over highways, neighbourhoods, infrastructure, in plain view of anyone who happened to look up? The possibility that formed in Marcus's mind was that being seen might be part of the purpose. Not disclosure exactly, but not complete concealment either. A middle ground. Visible enough to be documented, but ambiguous enough to remain officially unexplained. Chapter 7. The behaviour that doesn't match surveillance. Marcus had long assumed that if the black triangles were real, they represented surveillance technology. It was the simplest explanation that fit the observed behaviour. The craft were gathering intelligence, whether for military purposes or something else. But as he compiled more reports and analysed the patterns of behaviour, surveillance started seeming like an incomplete explanation. Surveillance operates on principles of efficiency and discretion. You want to gather information while minimising detection. Modern surveillance can be conducted from high altitude, from orbit, through digital means, in ways that are far less visible than hovering a massive craft over populated areas. Yet black triangles repeatedly positioned themselves in ways that guaranteed observation, not just occasionally spotted, but deliberately maintained in positions where witnesses could see them clearly, sometimes for extended periods. A caller from Virginia described watching a triangular craft hover over a shopping centre parking lot for over 30 minutes. The mall was closed, but security guards, late-night workers, and random passers-by all had clear views. The craft made no attempt to hide, climb to higher altitude, or move to a less visible location. Another report from Arizona detailed a craft that paced a highway for miles, maintaining position above the roadway where multiple drivers could observe it. This continued for approximately 20 minutes before the craft slowly moved away. This wasn't surveillance behaviour. This was something else. Marcus began examining where the craft positioned themselves. Not random locations, but specific types of areas. Residential neighbourhoods, infrastructure nodes, transportation corridors, population centres. The pattern suggested mapping or cataloguing rather than surveillance, as if the craft were documenting human activity patterns, settlement layouts, infrastructure networks. The thoroughness suggested systematic data collection, but the visibility suggested they weren't particularly concerned about being noticed during the process. An engineer Marcus corresponded with online made an observation that shifted his perspective. If you wanted to map human civilization thoroughly, you wouldn't do it from orbit or high altitude. You'd want low altitude, high resolution observation of how people actually use space. You'd want to see traffic patterns, electrical grids, water systems, all the infrastructure that only becomes clear at street level. And if you were significantly more advanced than the civilization you were observing, you might not be too worried about being spotted occasionally. This framing suggested something that Marcus found deeply uncomfortable. The black triangles might not be hiding because they didn't need to. The asymmetry of capability was so extreme that human observation didn't constitute a security concern. It was the behaviour pattern you would expect from a vastly superior intelligence studying a less advanced one. Methodical, thorough, unconcerned with occasional detection, because the observed civilization lacked any means to interfere with or threaten the observation process. Chapter 8. The Witnesses Who Stopped Talking. As Marcus deepened his research, connecting with witnesses through online forums and occasional email correspondence, he noticed a disturbing pattern. Some witnesses who had initially shared their experiences would suddenly go silent. Not all of them, and not in ways that suggested anything overtly sinister, but frequently enough to be noticeable. A witness from Tennessee named Robert had been actively discussing his multiple sightings in an online UFO research forum. His accounts were detailed, consistent and thoughtful. Then, abruptly, his post stopped. Marcus sent a private message asking if everything was okay. The response, when it finally came weeks later, was brief. "I've decided not to discuss this topic anymore. I appreciate your interest, but won't be participating in further conversations about it." Another witness, a woman named Elizabeth from Colorado, had shared her experience on several platforms, and even given a telephone interview to a UFO research group. Then she deleted her posts and stopped responding to messages. When Marcus managed to reach her by phone months later, she was polite but firm. "I just don't want to talk about it anymore. Nothing happened to me. I just don't see the point in continuing to discuss something I can't prove and that most people don't believe anyway." Some witnesses reported more concrete reasons for their withdrawal, follow-up visits from individuals claiming to be military or government officials, questions about their sightings that felt more like interrogations than friendly inquiry, suggestions that continued discussion might not be in their best interest. One witness described receiving a visit from two men in civilian clothing who showed identifications suggesting federal affiliation. They asked detailed questions about his sighting, seemed particularly interested in any photographs or video he might have taken, and mentioned that spreading unverified information about military aircraft could potentially be problematic. They were polite, even friendly, but the message was clear. Other witnesses reported no direct contact but experienced social consequences, ridicule from friends and family, concern from employers about the employee's judgment, the subtle message that being that person who believes in UFOs came with social costs. Marcus began to understand that silencing witnesses didn't require conspiracy or intimidation. Social pressure and self-preservation instincts were often sufficient. If sharing your experience brought more negative consequences than positive engagement, why continue? The effect was cumulative. Witnesses would share their stories initially, driven by the need to tell someone what they had experienced. But as they encountered skepticism, ridicule, or official discouragement, many would quietly withdraw from public discussion. This created a systematic filtering effect. The witnesses who remained vocal tended to be those with either exceptional conviction or, unfortunately, those whose accounts were sensationalized enough to attract attention, but lacked the credible details that made reports compelling. The thoughtful, credible witnesses with nothing to gain and everything to lose from public attention often chose silence. Chapter 9. A personal encounter. Marcus had been researching black triangles for nearly 6 years when his own experience occurred. Not a dramatic close encounter, but something subtle that confirmed everything he had been investigating. It was late summer, sometime around 2 a.m. Marcus had driven to a rural area about 40 minutes from his home, seeking darker skies for amateur astronomy. He had a telescope set up in a field, observing deep sky objects when he noticed something wrong with the stars. A section of sky simply disappeared. Not clouds, which would have been visible in the ambient light. A geometric absence, triangular in shape, blocking out the stellar background. He looked up from the telescope eyepiece and saw it clearly. A dark triangular form, silent and massive, drifting slowly across the sky perhaps 1,000 feet above him. 3 dim, amber lights at the corners, exactly as countless witnesses had described. The silence was profound. Not just the absence of engine noise, but a quality of stillness that seemed to deaden even the normal night sounds. The crickets and distant traffic noise he had been peripherally aware of simply faded. Marcus watched for approximately 8 minutes by his estimate, though time felt uncertain. The craft moved with deliberate slowness, covering perhaps half a mile during his observation. Then, without acceleration or any visible change in behaviour, it simply moved beyond his field of view. When it was gone, the normal soundscape gradually returned. Crickets resumed their chorus. A car passed on a distant highway, the engine noise carrying clearly through the night air. Marcus stood there for perhaps 20 minutes, telescope forgotten, processing what he had just witnessed. He felt no fear, which surprised him. No sense of threat or danger. Just a profound confirmation that the accounts he'd been studying were accurate. The craft existed. They were real, and they operated exactly as witnesses had described. He packed up his equipment and drove home in silence, not listening to the radio, just thinking. He didn't immediately tell anyone about the experience. What would he say? That he had seen what thousands of others had seen? That the conspiracy theories were true? Or at least that something unexplained was definitely happening in the skies above? Over the following days, Marcus found himself changing how he thought about the phenomenon. Before, it had been an intellectual puzzle, a mystery to research and analyse. Now it was personal. He had seen it. He knew it was real, not in an abstract research sense, but in the immediate, undeniable way you know something when you experience it directly. No photographs, no video, no physical evidence, just the memory and the confirmation. He understood now why so many witnesses sounded the way they did when calling Art Bell. That tone of confused certainty. They weren't trying to convince anyone. They were simply describing what they had experienced, knowing it sounded implausible but unable to deny what they had witnessed. Chapter 10. What the triangles might be. After years of research and his own encounter, Marcus found himself considering possibilities he had initially dismissed as too speculative. The military explanation remained on the table, but it required accepting that some nation possessed revolutionary technology for decades without deploying it or allowing it to influence broader aerospace development. Possible, but increasingly implausible as years passed without any conventional application of the implied physics. The alternative explanations were more disturbing precisely because they were more consistent with the observed behaviour. Autonomous reconnaissance systems from an unknown origin. Not necessarily extraterrestrial, but not human either. Perhaps artificial intelligence operating independently, cataloguing and mapping human civilization with methodical precision. The behavioural pattern supported this. The systematic coverage of different geographic areas, the focus on infrastructure and population centres, the apparent lack of direct communication or interaction with witnesses. These were characteristics you might expect from automated systems executing a programmed mission, non-human observation platforms. This explanation aligned with the decades-long consistency of reports, the apparent indifference to being occasionally observed, and the technology that exceeded human capabilities. If the craft represented observation efforts by non-human intelligence, the patterns made sense. Long-duration study, systematic data collection, minimal interaction with the observed civilization, technology operating outside conventional physics, the silent operation, hovering capability, and reported acceleration characteristics suggested propulsion systems that didn't rely on conventional thrust. Whether this represented highly advanced human technology or something non-human, it implied physics beyond current public understanding. Marcus avoided dramatic, invasion narratives or apocalyptic scenarios. Nothing in the behaviour pattern suggested hostility or imminent threat. The craft had been reported for decades with remarkable consistency, and no escalation toward conflict or aggression. What the observations did suggest was quiet, persistent monitoring, as if human civilization was being catalogued, studied, documented by something capable of doing so without our permission and without particular concern for whether we noticed. The idea was unsettling, not because it was dramatic, but because it was mundane. Not an invasion, just observation. Not contact, just surveillance. Humanity being studied the way we might study animal populations or ecological systems, with professional detachment and methodical thoroughness. Epilogue. Why the story never ends. Marcus still listens to late-night radio, though Art Bell has been gone for years now. The format continues, the callers continue, and the black triangles continue to be reported. Same shape, same silence, same slow, deliberate movement over populated areas. The reports haven't escalated into anything more dramatic. No landings on the White House lawn, no global disclosure moment, just persistent, ongoing observation by craft that operate according to rules we don't fully understand. Art Bell once made an observation that stayed with Marcus. The truth is out there, but it's not evenly distributed. Some people see the craft, most don't. Some governments acknowledge the phenomenon, most deflect. Some witnesses speak publicly, many choose silence. The pattern continues because it serves some purpose we can only guess at. The black triangles perform their systematic mapping, their methodical observation, their quiet presence in the skies above human civilization. Marcus thinks often about his own sighting, that moment of confirmation that moved the phenomenon from abstract research to personal knowledge. He wonders sometimes if being a witness changes something, if there's any meaning to having seen rather than simply having heard. But mostly he thinks about the implications of the one detail that seems most significant. The craft are visible when they could presumably remain hidden. If they wanted complete secrecy, surely they could achieve it. The technology that allows silent hovering and physics-defying movement would certainly allow better concealment. But they don't hide completely. They allow themselves to be seen, regularly and consistently, by thousands of witnesses over decades. That choice, if it is a choice, suggests something about intention. Not disclosure exactly, but not total concealment either. A middle ground. Visible enough to be documented, but ambiguous enough to remain officially unexplained. Marcus considers the possibility that we're being slowly acclimated, that the persistent low-level exposure to these craft over decades is preparing human consciousness for some eventual broader acknowledgement, or perhaps the visibility is simply a byproduct of the observation process, neither intended nor particularly concerning to whatever intelligence operates the triangles. He remembers the caller from years ago, the one who triggered his interest in this mystery. That voice describing the silent triangle drifting over an Arizona highway, and the simple statement that defined everything that followed. Planes don't move like this. They don't. And whatever these objects are, they've been in our skies for decades, operating according to their own logic, pursuing their own purposes, occasionally visible to those who happen to look up at the right moment. The story doesn't end because the phenomenon continues. Black triangles are still reported today by credible witnesses describing consistent details across vast geographic and temporal spans. Marcus has stopped trying to convince anyone of anything. He shares information when asked, conducts his research quietly, and accepts that most people will remain unaware or unconvinced until they have their own experience. The final thought that occupies his mind is perhaps the most unsettling aspect of the entire mystery. If they wanted to stay hidden, we would never see them. The fact that we do, that they allow themselves to be observed, that they maintain visible positions over populated areas for extended periods, suggests the visibility is acceptable to them, perhaps even intentional. We're being watched by something that wants us to know we're being watched, but only ambiguously enough that we can't quite be certain. And that uncertainty, that persistent question mark in the night sky, might be exactly the point. Before we begin tonight's investigation, if you're enjoying this content, please consider using your hype points on this video. It helps the channel more than you could possibly know, and it allows us to keep bringing you these deep dives into the unexplained. Also, if you'd like, drop a comment letting us know what time it is where you are and where in the world you're listening from. We absolutely love seeing where everyone is tuning in from around the globe. And a special thanks to Justin for suggesting this story. Now, let's get into it. Intro. The Discovery. December 2020. National Archives, College Park, Maryland. The fluorescent lights hummed their familiar drone as Laura Benton wheeled another cart of Cold War materials into the processing room. After 16 years as an archivist, she'd developed a rhythm: log the box number, check the inventory list, remove each item, photograph, digitize, refile, repeat. She'd processed thousands of documents this way: missile telemetry data, reconnaissance photographs, strategic planning memos, the bureaucratic detritus of the nuclear age, now declassified and catalogued for researchers who would probably never look at most of it. Box CW-4789L contained film reels from Johnston Atoll, the remote Pacific island that had served as a launch site for high-altitude nuclear tests in the early 1960s. Laura had processed dozens of similar boxes: launch footage, tracking data, atmospheric readings, nothing unusual. She pulled out the third canister and noticed the label was handwritten rather than typed. That was odd, but not unprecedented. Field personnel often labelled reels on site before sending them back to archives. The label read, USF Tracking Reel, Johnston Island, July 1962. Do not duplicate. Laura made a note of the restriction. Probably contained classified camera angles or revealed equipment specifications that were still sensitive even after all these years. She'd seen similar warnings before. She set up the projector, threaded the film with practiced hands and dimmed the lights. The screen flickered to life. The footage was grainy, black and white, shot from what appeared to be a ground-based camera tracking the sky. Time code ran along the bottom edge. July 9th, 1962. 0900 hours, Zulu time. Starfish Prime. The most powerful nuclear weapon ever detonated in space. 1.4 megatons at an altitude of 250 miles above the Pacific Ocean. Laura had seen footage of Starfish Prime before. It was one of the most documented nuclear tests in history. The detonation had knocked out streetlights in Hawaii, disrupted radio communications across the Pacific, and created artificial auroras visible from Hawaii to New Zealand. The countdown proceeded in silence. Film reels from this era rarely included audio. She watched the sky, waiting for the flash. And then it came. The screen went white. The nuclear fireball expanded, a perfect sphere of light against the darkness of space. The camera's exposure struggled to compensate, creating that familiar bloom effect around the detonation point. Laura had watched this sequence dozens of times in other footage. She knew what came next. The fireball would fade, the camera would readjust, the sky would return to black. But in that half second before the exposure corrected, she saw something else. A shape, a curve, an arc. She stopped the projector, rewound 10 frames, advanced slowly, frame by frame. There. The nuclear flash had illuminated something above the detonation point. Something massive. Something that shouldn't have been there. It wasn't clouds. The curvature was too regular, too precise. It wasn't aurora. The edges were too defined. It wasn't an artifact of the film. The shape remained consistent across multiple frames, with three-dimensional depth and shadow. It was a structure. Laura felt her pulse quicken. She advanced the film frame by frame, studying the shape. It appeared to be an arc, like a section of an enormous dome, positioned above the Earth's atmosphere. The nuclear flash had backlit it for just a fraction of a second, long enough for the camera to capture its outline against the void of space. She checked the time code again. This footage was taken from Johnston Island, which meant the camera was looking northwest toward the detonation point. The structure appeared to be between the camera and the blast, which meant it was somewhere in the upper atmosphere or low orbit. But that was impossible. There were no structures in orbit in 1962. The first American satellite had launched just 4 years earlier. The International Space Station wouldn't exist for another 4 decades. In July of '62, humanity had barely managed to put a man in orbit. So what was this? Laura rewound the film and played it again. The structure was still there, solid, unmoving, massive enough to be visible from hundreds of miles away. She needed to document this. She switched on the digitization equipment and began capturing the frames. The old projector clacked and whirred as the film advanced through the scanner. Each frame converted to a digital file stored on the archive's internal network. She was halfway through the scan when the door opened. Laura looked up. 2 men stood in the doorway, dark suits, no ties. One was older, grey-haired, with the kind of weathered face that suggested a career spent outdoors. The other was younger, maybe mid-30s, with the alert posture of someone trained to move quickly. Neither of them wore identification badges. "Miss Benton," the older man said. Not a question, a statement. He knew her name. "Can I help you?" Laura asked, her hand instinctively moving toward the phone on her desk. The younger man moved to the projector with practiced efficiency. He didn't ask permission. He simply unplugged the power, cord, and began removing the film reel. "Hey, wait," Laura said, standing. "That's archive property. You can't just—" "You're done for the day, Miss Benton," the older man said. His voice was calm, almost gentle, but it carried absolute authority. "Please gather your personal items and come with us." "I don't understand. Who are you?" "We're escorting you out. That's all you need to know." The younger man had already secured the film reel in a metal case he'd brought with him. He unplugged her computer workstation without shutting it down. The screen went black mid-scan. "I need to log this properly," Laura protested. "There are procedures." "The procedures have changed," the older man said. "Come with us. Now." Something in his tone made it clear this wasn't a request. Laura grabbed her purse, her mind racing. She hadn't done anything wrong. This was declassified material. She was following standard archival protocols, but these men didn't seem to care about protocols. They walked her through the archive building in silence. Other staff members glanced up from their work, then quickly looked away. The older man held her arm gently but firmly, the kind of grip that communicated control without causing pain. They escorted her to the parking lot. Her car sat in its usual spot, illuminated by the late afternoon sun. The older man released her arm. "Go home, Miss Benton," he said. "Forget what you saw. Consider it classified retroactively." "I don't—" "Go home." Laura got in her car. Her hands were shaking. She sat there for 20 minutes, watching the archive building in her rearview mirror, trying to process what had just happened. She'd been processing declassified materials, public record. Anyone with a researcher card could request access to those files. So why had 2 men in suits just confiscated a film reel that was supposed to be open to the public? And more importantly, what was that structure in the footage? That night, sitting at her home computer, Laura went through her archive access logs. The digitization had been interrupted, but the first few frames had already uploaded to the network before the men arrived. She found one frame, just one, the clearest shot of the structure, captured at the exact moment when the nuclear flash provided maximum illumination. She saved it to a USB drive. Then she deleted it from the network. Laura knew aerospace historians. She'd worked with dozens of them over the years, helping them navigate the archive's classified materials. One name came to mind: Evan Mercer. He'd written extensively about Cold War programs and had a reputation for taking strange leads seriously. She composed an email, short, simple, attached the image. "Do you know what this could be?" She hit send. 2 days later, Laura Benton's phone went straight to voicemail. Her apartment stood empty, the door locked, her car still parked in its assigned space. The National Archives received her resignation, letter via email, effective immediately, with no forwarding address. Her supervisor tried calling her emergency contacts. Her parents hadn't heard from her. Her sister didn't know where she'd gone. Nobody at the archive knew anything except that 2 men in suits had escorted her out on Tuesday afternoon. The film reel from box CW-4789L was logged as lost in processing. Equipment failure. A common occurrence with old reels. Nothing suspicious. But in Ohio, Evan Mercer opened an email from an archivist he'd worked with 3 years ago on a book about spy satellites. He clicked the attachment and stared at the image on his screen. A nuclear detonation. A flash. And behind it, illuminated for just a fraction of a second, something that shouldn't exist. Evan zoomed in on the image, studying the curve of the structure, the way the light fell on its surface, the shadows that suggested depth and dimension. Then he picked up his phone and started making calls. He didn't know it yet, but he'd just inherited the most dangerous investigation of his career, and somewhere in Maryland, Laura Benton's empty apartment was being thoroughly cleaned by people who didn't exist in any government database. Chapter 1. The Impossible Tests. Evan Mercer's office occupied the second floor of a converted warehouse in Columbus, Ohio. 3 rooms filled with filing cabinets, reference books, and boxes of declassified documents he'd accumulated over 15 years of research. His specialty was Cold War aerospace programs, the classified projects that pushed the boundaries of what humanity thought possible during the nuclear age. He'd written 3 books, the first on the Corona Spy satellite program, the second on early missile defense concepts, the third on Project West Ford, an attempt to create an artificial radiation belt using millions of copper needles in orbit. All of them based on painstaking research through declassified archives, FOIA requests, and interviews with retired military and scientific personnel. The image Laura Benton had sent him didn't fit anything he'd researched before. He printed it out, pinned it to his wall, stared at it for an hour. Then he went to his filing cabinets and pulled every folder related to high-altitude nuclear testing. Operation Fishbowl. He knew the basic history. Part of the larger Operation Dominic series in 1962, Fishbowl had conducted multiple nuclear detonations in the upper atmosphere and low orbit. The stated purpose was to study EMP effects and radiation belt responses. The test had created spectacular visual displays, but had also disrupted satellite operations and radio communications across the Pacific. Evans spread out the official test data on his desk. Launch dates, yield specifications, detonation altitudes, camera locations, all meticulously documented in the declassified reports. But he'd learned over the years that what wasn't in the reports often mattered, more than what was. He started with Operation Argus, August through September 1958. 4 years before Fishbowl, 3 nuclear detonations in the Van Allen radiation belts, conducted from Navy ships in the South Atlantic. Argus had remained classified for 24 years. The public didn't learn about it until 1982, when the government finally declassified the mission. That unusually long classification period had always interested Evan. Most nuclear tests were declassified within a decade. Argus stayed secret for nearly a quarter-century. He'd obtained the Argus technical reports years ago for his Project West Ford book. He pulled them out now and read them with fresh eyes. The language was peculiar. Evaluate radiative responses in artificial belt structures. Mapping of containment boundaries at high altitude. Measurement of artificial barrier fluctuations under nuclear loading. Evan circled those phrases. Containment boundaries, artificial barrier, nuclear loading. He'd read hundreds of nuclear test reports. This terminology was unique to Argus. Other tests talked about yield measurements, fallout patterns, atmospheric effects. They used standard nuclear weapons terminology, but Argus used the language of testing barriers, of measuring responses, of evaluating containment, as if they weren't testing weapons at all, as if they were testing something else. Evan made notes and moved on to Fishbowl. Operation Dominic, the umbrella program, conducted 43 nuclear tests throughout 1962. Fishbowl represented the high-altitude subset, the tests with exotic names, Bluegill Prime, Starfish Prime, Checkmate, Kingfish, Tightrope, detonations at altitudes ranging from 12 miles to over 200 miles. The official outcomes were well documented. Starfish Prime, the largest test, had been visible from Hawaii to New Zealand. The artificial auroras persisted for several minutes. The EMP knocked out streetlights in Honolulu, 900 miles from the detonation point. Radio communications across the Pacific were disrupted for hours. All expected effects from a 1.4 megaton detonation at high altitude. But Evan found anomalies in the technical appendices. An Air Force tracking station report mentioned unexpected shockwave reflections detected by multiple radar installations. A Navy camera operations log noted persistent equipment anomalies requiring calibration review after Bluegill Prime. A Los Alamos radiation measurement summary referenced secondary energy returns inconsistent with atmospheric models. These weren't headline findings. They were buried in footnotes and appendices, the kind of technical minutiae that most researchers skipped over. But Evan had learned to pay attention to footnotes. That's where the interesting questions lived. He cross-referenced the radar reports. 3 separate installations had detected the anomalous reflections. All at approximately the same altitude, right around 200 miles above Earth's surface, the same altitude where Laura's photograph showed the structure. Evan pulled the personnel files next. Fishbowl had involved dozens of scientists and military officers, but 2 names appeared repeatedly in the documentation. John Wolfe, radiation belt specialist, Princeton graduate. He'd published extensively on Van Allen belt physics before Fishbowl, then abruptly shifted his research focus afterward. No more papers on radiation belts. Instead, he'd moved into general plasma physics, never directly addressing high-altitude phenomena again. John Craven, Navy officer, project officer for Argus, technical advisor for Fishbowl, career military man with top-level security clearances. After Fishbowl, he'd moved to classified submarine programs and never spoke publicly about the nuclear tests. Both men had left behind personal notes in their archived papers. Evan had obtained copies years ago. He read them again now. Wolfe's notes from June 1962, just before Bluegill Prime. Preliminary models suggest behaviour inconsistent with known magnetospheric responses. Need higher altitude detonation for confirmation. Craven's notes from July, right after Starfish Prime. Results exceed expectations. Further testing may be inadvisable. Recommend consultation with theoretical physics group. Inadvisable. That word stuck with Evan. Nuclear tests were massive government operations involving thousands of personnel and millions of dollars. You didn't call them inadvisable unless something had gone seriously wrong, or seriously unexpected. Evan looked at the test schedule. Fishbowl had been planned to continue through November. Multiple additional tests at various altitudes. But after Starfish Prime in July, the testing pace changed. Delays, equipment failures, modified flight plans. Bluegill Prime in June had failed, the missile detonating early at around 30 miles altitude. Bluegill Double Prime in July had failed, exploding on the launch pad. Starfish Prime succeeded in July, detonating at 250 miles. Bluegill Triple Prime in October succeeded at 30 miles. Checkmate in October failed, detonating early. Kingfish in November succeeded at 60 miles. The pattern was revealing. The only high-altitude test that worked was Starfish Prime. Everything after that stayed below 100 miles, and half of those tests failed, as if something was stopping them from going higher. Evan made a timeline on his whiteboard. Argus in 58, 4 years of apparent analysis, then Fishbowl in 62, focusing on even higher altitudes. One successful high-altitude test, then a sudden shift to lower altitudes and multiple failures. He stepped back and looked at the timeline. It looked less like a testing program and more like an escalation followed by a retreat, as if they'd tried something at high altitude and gotten a response they didn't expect. He needed to know what the scientists had been thinking before and after these tests. The official reports would be sanitized. But scientists kept personal correspondence. They shared preliminary findings with colleagues. They wrote conference papers and grant proposals. Evan started with James Van Allen. Van Allen had discovered the radiation belts in 1958 using data from the Explorer satellites. The belts bore his name. He was the world's foremost expert on near-Earth radiation environments. If anyone would understand what was happening during these high-altitude tests, it would be Van Allen. And Van Allen's public statements showed a curious pattern. Before Argus, he'd been vocal about the dangers of nuclear testing in space. He'd written op-eds calling the tests reckless experimentation. He'd testified before Congress, warning that we didn't fully understand the radiation belts and shouldn't disturb them with nuclear weapons. Then Argus happened. After Argus, Van Allen went quiet for several months. No more op-eds, no more public warnings. When he finally spoke about high-altitude testing again, his position had shifted. By early 1962, just months before Fishbowl, Van Allen publicly supported the tests. He called them necessary for scientific understanding of near-Earth space environment. This was a complete reversal. Scientists changed their minds based on new evidence, certainly, but Van Allen's shift was abrupt and unexplained. He'd gone from calling the tests reckless to calling them necessary, with no public explanation of what had changed his mind. Evan had obtained Van Allen's archived correspondence from the University of Iowa years ago for background research. He'd skimmed through it then, looking for information about the Explorer satellites. Now he read it more carefully, focusing on the period between Argus and Fishbowl. Most of the letters were routine academic business, conference invitations, peer review requests, graduate student recommendations, but one letter, dated April 1962, stood out. It was addressed to a colleague at Los Alamos. The main body discussed a proposed symposium on space plasma physics, standard stuff. But in the second paragraph, almost as an aside, Van Allen had written, "Our earlier assumptions about the belt's origins may require serious revision. I hesitate to discuss this in writing, but the implications of the Argus data suggest phenomena we hadn't considered. I hope we can discuss this in person at the symposium." Evan read that paragraph 5 times. Earlier assumptions about the belt's origins may require serious revision. Van Allen had discovered the radiation belts. He'd published the definitive papers on their structure and properties. Those belts were named after him. If he was saying the assumptions about their origins needed revision, that meant something fundamental had changed. Something he'd learned from Argus. Something he hesitated to discuss in writing. Evan picked up his phone and called the University of Iowa Physics Department. After several transfers, he reached the archivist responsible for Van Allen's papers. "I'm looking for any additional correspondence from Van Allen in 1962, Evan said, "particularly anything related to high-altitude nuclear testing." "We have the collection you already accessed," the archivist said. "That should include everything from that period." "Are there any restricted materials? Anything that wasn't released?" A pause. "There are some letters that were donated with restrictions. Family request. They won't be available until 2050. "What's in them?" "I can't discuss restricted materials, but I can tell you they're mostly personal correspondence, nothing scientific." "Did Van Allen write anything else about Argus or Fishbowl?" "Not in the unrestricted collection. He gave several talks about the tests, but those were general discussions. No technical details." Evan thanked her and hung up. Van Allen had been careful. Whatever he'd learned from Argus, whatever had made him change his position on high-altitude testing, he'd kept it out of his archived papers, but he'd changed his position for a reason. Evan looked at the photograph on his wall. The structure, the arc, the impossible object that shouldn't exist at 200 miles altitude in 1962. He thought about containment boundaries and artificial barriers, about scientists changing their positions, about tests that succeeded once and then failed repeatedly. And he realized something that made his chest tighten. What if Fishbowl wasn't a weapons test at all? What if it was an attempt to break through something? Chapter 2. The scientists who knew Evan spent the next 2 weeks filing Freedom of Information Act requests. He'd done this hundreds of times for his books and consulting work. The process was tedious but usually productive. Government agencies were required by law to respond, though they often heavily redacted sensitive information. He requested all documents related to high-altitude nuclear testing between 1958 and 1965. Radar tracking data from the fishbowl tests, camera operation logs, radiation measurement reports, scientific analysis memos, anything that might explain the anomalies he'd found. The responses came back slowly. Most were heavily redacted, large sections blacked out, entire pages sometimes reduced to just the header and footer, everything else classified. But then he got lucky. One document came back completely unredacted, a Los Alamos National Laboratory internal memo that had been declassified in 1998 but never properly catalogued. The FOI processor had found it in a misfiled box and sent it without realising it should have been reviewed for redactions. LA 273 Reflection Event Assessment, July 12th, 1962. Evan stared at the document header, July 12th. 3 days after Starfish Prime. The memo was 3 pages of dense technical language, radar measurements, energy calculations, spectral analysis. Most of it required a physics degree to fully understand, but the conclusion was written in plain English. The returning shock wave was not consistent with interaction with ionosphere or magnetosphere. Energy return suggests reflection from solid or semi-solid boundary at approximately 220 miles altitude. Further analysis terminated by directive. All personnel are to direct future inquiries to Project Officer. Signed by Darrell Froman, Deputy Director of Los Alamos National Laboratory during the 1960s, one of the top administrators in the entire nuclear weapons program. Evan read the conclusion again. Reflection from solid or semi-solid boundary. Not atmospheric effects, not radiation belt interactions, not measurement error, a boundary. Something solid enough to reflect a nuclear shock wave. And analysis had been terminated by directive. Someone had ordered them to stop looking into this. Evan made copies of the memo and stored them in 3 different locations. This was the kind of document that had a tendency to disappear if the wrong people noticed it had been released. Then he started tracking down anyone who'd worked at Los Alamos during the fishbowl period. Most of the scientists were dead. Nuclear weapons research in the 1960s had involved a lot of radiation exposure, and many of the researchers hadn't lived to old age. The survivors were scattered across the country, mostly in retirement. Evan made dozens of calls. Many people refused to talk. Some claimed they didn't remember anything about fishbowl. A few hung up as soon as he mentioned high-altitude testing, but one person agreed to talk. On the condition of complete anonymity, Margaret Reeves, 83 years old, living in a retirement community in New Mexico. She'd been Darrell Froman's administrative assistant from 1960 through 1964. She remembered the memo. "That was a strange time," she said when Evan called. Her voice was thin but steady. A lot of confusion after that big test in July, the one that made the lights go out in Hawaii. "Starfish Prime," Evan said. "That's the one. The data came back and nobody knew what to make of it. I heard the scientists arguing about it in the hallways. They kept saying the numbers didn't make sense." "What numbers?" "The measurements from the tracking stations. They were getting readings that shouldn't have been there, like echoes but from the wrong direction. One scientist said it was like the blast had hit a wall and bounced back." Evan felt his pulse quicken. "Did they figure out what caused it?" A long pause. Evan could hear her breathing on the other end of the line. "Miss Reeves?" "There was a structure," she finally said. Her voice dropped to almost a whisper. "That's why they stopped the tests." "What kind of structure?" "I don't know. I wasn't a scientist. I just heard them talking. They were scared. I'd never seen those men scared before. They'd built the atomic bomb. They'd watched hundreds of weapons tests. But after Starfish Prime, they were scared." "Did anyone say what the structure was?" "No. Mr. Froman called a meeting, closed door. When they came out, he told me to destroy all the analysis documents, everything related to the reflection event. He said it was being classified at a higher level. But you remember the memo? I typed it before the classification order came down. That was the last official analysis they did. After that, everything went quiet. Why did they stop? Another long pause. Miss Reeves, please. Why did they stop the tests? Because they realised they weren't alone, she said quietly. That's what Mr. Froman told me. He said humanity wasn't alone, and we just tried to attack something we didn't understand. He told me to forget everything I'd seen, for my own safety. Did he say who built the structure? No, he wouldn't talk about it after that. None of them would. It was like a wall of silence came down. Even the scientists who'd been arguing in the hallways stopped discussing it. Someone put pressure on them, high-level pressure. Evan had more questions, but Margaret ended the call. She'd said too much already. She knew it. He could hear the fear in her voice. He sat in his office staring at his notes. A structure, reflection signatures, scientists who'd been scared, analysis terminated by directive. This wasn't a measurement error, it wasn't atmospheric anomaly. They detected something real, something solid, something that reflected a nuclear shockwave back to Earth. And someone had ordered them to stop investigating it. Evan pulled up the footage from the other fishbowl tests. He'd obtained copies of the declassified camera recordings years ago. He'd watched them before, but casually, just getting a sense of what high-altitude nuclear tests looked like. Now he watched them systematically, looking for anomalies. Bluegill Prime, June. The missile had launched successfully but experienced an electrical failure at 30 miles altitude. The warhead detonated early. The official report blamed component malfunction. But Evan noticed something in the telemetry data. The failure occurred at exactly 29.7 miles. The missile systems had been functioning normally up to that point. Then multiple electrical systems failed simultaneously. Not a single component. Multiple systems, all at once, at a specific altitude. Bluegill Double Prime, July. The missile never left the launch pad. Electrical failure during the countdown sequence. The warhead was damaged and had to be recovered. The official report blamed wiring issues, but Evan noticed the countdown had proceeded normally until the moment of ignition. Then the entire missile's electrical system shut down. Not a fuel problem, not a mechanical failure. Electrical systems failure. Same as Bluegill Prime, Starfish Prime, July 9th. Successful launch. Successful detonation at 250 miles. The only completely successful high-altitude test in the entire fishbowl program. And that was when Laura's photograph showed the structure. After Starfish Prime, the program changed. No more 200-mile altitude tests. Everything dropped to under 100 miles. Bluegill Triple Prime, October. Successful detonation at 30 miles. Checkmate. October. Another electrical failure. Detonation at 60 miles. Well below the planned altitude of 140 miles. Kingfish. November. Successful detonation at 60 miles. But the warhead yield was only half what it should have been. The official report blamed weapons design issues. Evan made a chart. He plotted altitude against test success rate. Below 50 miles, high success rate. 50 to 100 miles, mixed results. Above 100 miles, only one success, followed by multiple failures. The pattern was clear. Something was interfering with the tests at high altitude. Not mechanical problems, not design flaws. Something external, as if something was stopping them from going higher. Evan thought about the structure in Laura's photograph. The massive arc, the defined edges. If that structure existed at around 200 miles, and if the missiles were experiencing electrical failures as they approached that altitude, then maybe those failures weren't failures at all. Maybe they were countermeasures. He needed more information about what the scientists had been thinking. The official reports were sanitized, but scientists talked to each other. They shared ideas. They wrote proposals. He started searching for references to high-altitude phenomena in the scientific literature from the early 1960s. Most papers were about the radiation belts themselves. Van Allen's work, studies of solar particles, magnetosphere physics, standard space science. But he found a few odd references buried in conference proceedings and grant proposals. A 1960 proposal from the Air Force Office of Scientific Research referenced containment boundary studies at orbital altitudes. A 1961 symposium abstract mentioned artificial structures in near-Earth space environment. A 1963 grant application from Douglas Aircraft Company described resonance mapping of high-altitude geometric structures. These weren't mainstream topics. They were buried in technical documents that most people would never read. But they were there. A scattered paper trail suggesting that some scientists were investigating something unusual at high altitude. Evan started making phone calls. He needed to talk to anyone who'd been involved in these obscure projects. It took him 4 days to find someone willing to talk. Richard Torres, retired engineer from Douglas Aircraft Company, 78 years old, living in Henderson, Nevada, just outside Las Vegas. He'd worked on classified aerospace projects throughout the 1960s. "You're asking about some pretty old stuff," Torres said when Evan called. "Most of it's probably still classified." "I'm just trying to understand some anomalous data from the fishbowl tests," Evan said carefully. "I found a reference to resonance mapping work at Douglas in '63. Was that related to the nuclear tests?" A long silence on the other end. "Mr. Torres?" "I worked on something in '63, Torres said slowly. "Suborbital resonance mapping system. It was a weird project. We built equipment to measure echo patterns at high altitude. I never knew what it was for. They never told us. We just built the hardware and processed the data." "What kind of data?" "Reflection patterns. We were using high-powered radar to map something above the atmosphere. The signals would go up, hit something and bounce back. We'd measure the return signal and create a map." "A map of what?" "I didn't know at the time. I just processed numbers, created topographical plots, sent the results up the chain. But the plots showed structure, geometry, regular patterns at specific altitudes." Evan's heart rate increased. "What kind of altitude?" 200 to 240 miles, right in the lower orbital range. The structure was massive, curved, like we were mapping the inside of a sphere. "Did anyone ever tell you what you were mapping?" "No. The project shut down in November '63. Abrupt termination. They dismantled the equipment, reassigned all the personnel. My supervisor told me to forget I'd ever worked on it." "Do you have any documentation from the project?" "I wasn't supposed to keep anything, but I made copies of some reports. I thought someday people might want to know what we'd been working on. After all this time, I figure the classification has probably expired." Evan felt a surge of excitement. "Would you be willing to share those copies with me?" Another silence. "Can you come to Henderson?" Torres asked. "I don't like talking about this on the phone." 2 days later, Evan was sitting in Richard Torres's living room. The house was modest, filled with photographs of grandchildren and mementos from a long aerospace career. Torres moved slowly, age and arthritis limiting his mobility, but his mind was sharp. He handed Evan a folder. Old photocopies, yellowed with age. The paper stock dated from the 1960s. "Space Cave Preliminary Report, July 1963, the cover page read. Evan opened the folder carefully. The documents inside were marked with security classifications that had probably expired decades ago. He started reading. The first page described the project purpose in careful bureaucratic language. Development of suborbital resonance mapping capability for detection of structured phenomena at high altitude. The second page detailed the equipment specifications, high-powered radar transmitters, sensitive receivers, signal processing equipment, all designed to detect echoes from objects in low orbit. But it was the data section that made Evan's hands tremble. Test results from July 10th through July 30th, 1963 show consistent reflection signatures at altitudes between 210 and 240 miles. Reflection strength indicates solid or semi-solid material with geometric properties. Structure appears symmetrical across multiple measurement angles. Estimated surface area exceeds 10,000 square miles. Curvature analysis suggests spherical or near-spherical geometry with Earth at approximate centre. Material properties unknown. Further study recommended. Evan looked up at Torres. Did you understand what this meant when you wrote it? Torres shook his head. Not at the time. I just processed the numbers. It wasn't until you sent me that photograph that I understood what we'd been looking at. You're saying there's a structure surrounding Earth at 200 miles altitude. That's what the data showed. We weren't mapping the Earth. We were mapping what's above it. Evan turned to the next page. It contained a rough plot of the reflection data, a curved line representing the structure's surface. Measurement points plotted along its length, error bars showing the uncertainty in each measurement. The curvature was consistent with a sphere centred on Earth. If you extended the arc, it would form a complete shell around the planet at approximately 220 miles altitude. What happened after this report? Evan asked. Nothing. That was the last report. 2 weeks later they shut the project down, told us it was budget cuts, but I talked to the other engineers. They detected something, and someone high up decided we shouldn't be looking at it. Do you know who made that decision? No, but it came from somewhere with serious authority. The project had Air Force funding, good funding. Projects like that don't get cancelled unless someone very important wants them cancelled. Evan photographed every page of the report. Torres watched him work, then said something that made Evan's blood run cold. You know what the weird part was? We kept detecting the structure for weeks after the project ended. What do you mean? The equipment was still running for a while. We hadn't dismantled it yet, so I kept taking measurements. Unauthorised, but nobody was paying attention anymore. The structure was still there. Same altitude, same curvature, same reflection properties. Whatever it was permanent, not temporary, not experimental. It had been there all along, and we'd only just noticed it. Evan thought about the timeline. Argus in 58, 4 years of analysis, Fishbowl in 62, trying to reach higher altitudes, Space Cave in 63, mapping what was up there, and then silence, complete shutdown of any investigation. Mr. Torres, in your professional opinion, what was that structure? Torres was quiet for a long moment. When he spoke, his voice was careful, measured. I'm an engineer, not a scientist. I deal with things I can measure and calculate. The measurement said there was structure at high altitude, solid material, geometric patterns, spherical curvature. Those are facts. What it means. He shook his head. That's above my pay grade, but I'll tell you what I think. Someone put something up there, a long time ago, long before we had rockets or satellites, and in the 60s we finally got high enough to notice it. Who put it there? That's the question, isn't it? That's the question they didn't want us asking. Evan thanked Torres and drove back to his hotel. He sat in the parking lot for an hour, looking through the photographs he'd taken of the Space Cave report. Everything pointed to the same conclusion. There was a structure surrounding Earth at high altitude. The military had known about it since at least Argus in 58. They'd tried to investigate it with nuclear weapons in 62. They'd tried to map it with radar in 63. And then they'd classified everything and shut down all research. But why? What was so threatening about a structure in orbit that it required total suppression? Evan thought about Dyson's note from the symposium. Not invasion. Containment. They weren't worried about something attacking Earth. They were worried about something keeping humanity confined. A cage. A barrier. A wall between us and the rest of space. And the government had decided we weren't ready to know about it. Chapter 3. The hidden programs. Back in his office, Evan pinned the Space Cave report photographs to his wall next to Laura's image. The structure in the photograph matched the description in the report. Same altitude, same curvature, same geometric properties. 2 independent sources. a photograph from 62, a radar mapping report from 63, both showing the same thing, but he needed to know more about the government's response. How had they organised the cover-up? Who was involved? What programs had been created to study this phenomenon in secret? He started searching for references to high-altitude research programs from the 1960s. Not the public programs like Mercury and Gemini, the classified ones, the programs that existed in budget documents but nowhere else. Project Defender caught his attention first. Defender had been an early missile defence initiative from the late 1950s and early 60s. The official goal was to develop systems for shooting down Soviet ICBMs. Evan had written about Defender in his second book. He thought he knew the program well, but when he requested the complete archive of Defender documents, he found references he'd missed before. Sky Shield, Phase 2, Containment Interference Studies. That program name had been buried in a budget allocation document from 1961. Evan had skimmed past it years ago, assuming it was just another missile defence sub-study. Now he looked at it more carefully. The document listed 3 principal scientists: Nicholas Christopoulos, Greek physicist. He'd proposed the original concept for Operation Argus, the idea of using nuclear weapons to create artificial radiation belts. Brilliant but controversial, he'd worked on numerous classified projects throughout the 50s and 60s. Hans Bethe, Manhattan Project scientist, Nobel Prize winner, one of the most respected physicists of his generation. If Bethe was involved, this was serious theoretical work. Edward Teller, father of the hydrogen bomb, controversial figure known for pushing the boundaries of nuclear weapons design. He'd championed numerous extreme concepts, including nuclear-powered rockets and weapons that could destroy entire continents. These weren't minor researchers. These were 3 of the most important physicists in the American nuclear program. Their involvement suggested Sky Shield was more than a simple missile defense study. Evan found a digitized copy of the 1961 Sky Shield planning meeting notes. Most of the document was routine discussion of radar systems and tracking protocols, but in the margins, someone had made handwritten notes. The handwriting matched Nicholas Christopoulos' signature on other documents. Evan had seen enough of Christopoulos' papers to recognise his distinctive style. The note read, "Barrier exists. Question is, natural or manufactured?" Evan stared at that sentence. Barrier exists, not might exist, not possibly exists, exists. Present tense, definite. And the question wasn't whether it existed. The question was its origin. Natural or manufactured. This was written in early 1961, before the fishbowl tests, which meant they'd already known about the barrier before they started detonating nuclear weapons near it. Fishbowl hadn't been an exploratory test. It had been a targeted investigation of something they already knew was there. Evan dug deeper into the Defender archives. He found a second reference to Sky Shield in a 1962 technical review. This one mentioned radiation barrier properties and containment field interactions. Those weren't missile defense terms. Those were terms for studying a physical barrier at high altitude. He found a third reference in a 1963 document. This one was more explicit. Sky Shield. Phase 2 concluded that barrier phenomenon represents structured material of unknown origin. Conventional detection methods insufficient. Nuclear probe testing recommended. See Operation Fishbowl results for preliminary data. There it was. Direct confirmation that Sky Shield and Fishbowl were connected. They'd been studying the same barrier, and Fishbowl had been the nuclear probe testing phase. But the document was dated September 1963, after Fishbowl had ended, which meant this was a post-operation assessment, looking back at what they'd learned. Evan searched for any Sky Shield documents after 63. He found nothing. The program appeared to have ended abruptly, just like Space Cave, as if someone had decided all investigation should stop. He needed to find other programs that might have been studying this. The government wouldn't just give up on something this significant. They'd continue investigating, but under different program names, deeper classification, compartmentalized security. He started looking for references to atmospheric or orbital research in the mid-1960s. Anything that seemed unusually classified or involved the same scientists who'd worked on Sky Shield. He found several curious program references. Project HARP, High Altitude Research Program. Official purpose was studying ballistics and satellite deployment, but one budget document mentioned barrier penetration studies. Project GREAT, Geophysical Research at Extended Altitude Trajectories. This one was explicitly about launching probes above 200 miles, but funding ended abruptly in late 1962. Project Upshot, classification level so high that most documents just reference the program name without describing its purpose. But one personnel transfer order mentioned orbital boundary investigations. These programs had all operated in the early to mid-60s, all focused on high altitude, all classified, all terminated around 1963 or 64. The pattern was clear. The government had been running multiple programs to study the barrier, and then they'd shut all of them down simultaneously. Something had happened in 63 that made them decide investigation was too dangerous. Evan needed to know what that decision point was. He started looking for high-level policy documents from that period. He found it in a CIA memorandum from 1978. The memo had been declassified in 2012, but it had never been indexed properly, so it had languished in the archives unnoticed. OPF B-72, Post-Fishbowl Assessment. The date was interesting. 1978. 16 years after Fishbowl. Why were they doing a post-operation assessment so long after the tests? The memo was addressed to 4 recipients. Robert Varney, NASA official. He'd been involved in early satellite programs and had high-level security clearances. Colonel Francis Kane, Air Force Space Systems Division, career military officer specializing in orbital systems. Lloyd Berkner, geophysicist, pioneer in ionosphere research. He'd been on advisory committees for numerous classified programs, and one name that was redacted. Just a black rectangle where the name should have been. The memo's content was mostly administrative. Discussion of whether fishbowl-related documents should remain classified. Assessment of whether the data was still sensitive 16 years later. But the final paragraph made Evan's pulse quicken. Recommend total suppression of all evidence of the barrier phenomenon discovered during OPFB activities. Continued investigation poses unacceptable risk to social stability and international relations. Current monitoring protocols should continue indefinitely, but no new active investigation authorized. This position unchanged since original 63 directive. Barrier phenomenon, capital letters. They'd given it an official name, and the recommendation was total suppression. Not just classification, suppression, erasure of evidence, because investigation posed unacceptable risk to social stability. Evan thought about what that meant. Social stability, not national security, not military advantage. Social stability. They weren't worried about the Soviets learning about this. They were worried about the public learning about it. What would happen if humanity discovered there was a physical barrier preventing us from leaving Earth? What would that do to our sense of purpose, our space program, our philosophical and religious frameworks? The 1960s had been the height of space race optimism. We'd put men in orbit. We were planning moon landings. The future seemed unlimited. Space was the new frontier. How would people have reacted to learning that Frontier had a wall? That we were confined? Contained? Evan understood the suppression now. Not because the information was militarily sensitive, because it was psychologically destabilizing. Better to let people believe space was open and accessible than to tell them we were living in a cage. But the memo mentioned continued monitoring, which meant they hadn't stopped watching the barrier. They'd just stopped investigating it actively. Evan started looking for modern surveillance programs that might be monitoring high-altitude phenomena. This was harder. Recent programs were still classified. FOIA requests would take years to process, and most information would be heavily redacted. But he found a curious reference in an NSA budget justification from 1986. Continued surveillance of anomalous orbital reflections at radiative boundary layers. The memo was signed by Lieutenant General William Odom. He'd been NSA director in the mid-80s. Anomalous orbital reflections, radiative boundary layers. They were still watching it, still measuring it. 40 years after Fishbowl, which meant the barrier was permanent, not a temporary phenomenon, not an experimental installation. It had been there in the 50s, it had been there in the 60s, and it was still there in the 80s, and presumably still there now. Evan thought about the implications. A permanent structure at orbital altitude, surrounding the entire Earth, existing since before we had the technology to detect it. Someone had built this. Something had built this, and our government had known about it for 70 years and never told anyone. He needed one more piece of confirmation. He needed to find evidence that modern scientists were still encountering the barrier. He started searching for references to unusual observations from recent space missions. Satellite anomalies, atmospheric measurements that didn't fit models, anything that might indicate modern sensors were still detecting the structure. He found several curious reports. A 2012 NASA technical paper mentioned unexpected radar returns from orbital altitudes inconsistent with debris or satellite signatures. A 2016 Air Force Space Command memo referenced persistent anomalous readings from DSP satellites at radiative boundary regions. A 2019 SpaceX engineering report noted intermittent signal reflections from high-altitude sources, origin unknown. These were all carefully worded to avoid suggesting anything definitive, but the pattern was there. Modern spacecraft were still detecting something at the same altitude where the barrier had been observed in the 60s. Evan compiled everything into a timeline. 1958, Argus tests detect anomalous responses at high altitude. 1961, Sky Shield confirms barrier exists. 1962, Fishbowl attempts nuclear probe testing of barrier. 1963, Space Cave maps barrier with radar. All programs terminated. 1978, Assessment recommends continued suppression. 1986, NSA confirms continued surveillance. 2000 to present. Modern spacecraft still detecting the structure. 70 years of evidence. Multiple independent confirmations and complete suppression of the information. Evan sat back and looked at his research wall. Photographs, documents, timelines, quotes from scientists. All of it pointing to one inescapable conclusion. Earth was enclosed, not by accident, not by natural phenomenon, by design. Something or someone had built a physical barrier around our planet. A shell at approximately 220 miles altitude, large enough to be visible from the ground under the right conditions, solid enough to reflect nuclear shock waves, permanent enough to persist for at least 70 years. And the United States government had discovered it in the 1950s and decided humanity wasn't ready to know. Chapter 4. The modern connection. Evan might have stopped there, written a book, made his case with historical documents, but he wanted to know if the barrier was still being observed by modern systems. He started monitoring space industry news more carefully. SpaceX launches, satellite deployments, International Space Station operations, anything that might involve spacecraft operating near the 200-mile altitude where the barrier existed. Most launches went smoothly. Satellites deployed successfully. No unusual reports, but occasionally there were anomalies that caught his attention. In 2022, SpaceX launched a batch of Starlink satellites. These communication satellites operate in low Earth orbit, typically between 300 and 400 miles altitude. They carry cameras for Earth imaging and solar monitoring. One of these satellites captured an unusual image during a solar observation session. The image showed the sun's corona, but in the foreground there was a faint arc. A curve that didn't match any known orbital debris or satellite constellation pattern. NASA's explanation was brief. Sensor ghosting artifact common in space-based optical systems. No anomaly detected. But Evan obtained the raw image data through a contact at SpaceX. When he processed the image with enhanced contrast, the arc became clearer. It had depth, shadow properties, three-dimensional structure. He overlaid the arc with Laura's photograph from the fishbowl film. The geometry matched. Exactly. Same curvature, same altitude, same relative position to Earth's horizon. Whatever had been there in 1962 was still there 60 years later. Evan documented the match and started looking for other modern observations. He found several. A 2018 paper by Chinese satellite researchers mentioned unexpected microwave reflections from atmospheric boundary regions. A 2019 International Space Station crew report noted unusual visual phenomena during orbital sunrise at approximately 220 miles altitude. A 2020 amateur radio operator community discussion described persistent signal bouncing from unknown source at low orbital altitudes. None of these reports explicitly acknowledged a structure, but they all described observations consistent with a physical barrier at the same altitude. Evan found one more interesting reference, an astronaut quote that had been quickly dismissed as a misstatement. Jeremy Hansen, Canadian astronaut, highly experienced, not prone to making careless statements. In 2014, he'd given a presentation at a university about his time aboard the International Space Station. During the Q&A session, a student asked about the challenges of operating at orbital altitudes. Hansen's response was recorded. There are things I can't talk about regarding the upper atmospheric boundary, but I can say that the environment at those altitudes is more complex than the public realises. We observe phenomena that aren't fully explained by current models. Within hours, NASA issued a clarification. Hansen had been referring to classified military satellite operations. Nothing unusual, just standard operational security. But Evan noticed the specific phrase, upper atmospheric boundary. Not space, not orbit, boundary. The same terminology that kept appearing in the classified documents from the 60s. Barrier, boundary, containment. Hansen wasn't talking about satellites. He was talking about the structure. Evan tried to contact Hansen for an interview. The request was declined. Hansen's management company sent a polite email saying he wasn't available for interviews about technical spaceflight topics. But the quote was on record, and it matched everything else Evan had found. He compiled all the modern evidence into a comprehensive report. The historical tests from the 60s, the mapping data from Space Cave, the CIA memoranda, the NSA surveillance references, the modern satellite observations, the astronaut statement. All of it pointing to the same conclusion. There was a structure surrounding Earth. It had been there for at least 70 years, possibly much longer, and our government knew about it and was actively suppressing the information. Evan prepared to publish. He had enough evidence, enough documentation, enough credibility as a researcher to get mainstream attention. He wrote a draft article, 15,000 words, footnoted, carefully worded. He wasn't claiming to know what the structure was or who built it. He was simply presenting the evidence that it existed and that the government knew about it. He sent the draft to 3 colleagues for peer review. All 3 were experienced researchers who'd published on classified programs before. He trusted them to give honest feedback. 2 of them responded positively. The evidence was compelling. The documentation was solid. They encouraged him to publish. The 3rd colleague, a retired Air Force intelligence officer, sent a different kind of response. Evan, this is fascinating work, but I need to warn you. This topic is actively protected. Not just classified, protected. I've seen researchers lose their careers investigating similar phenomena. Be very careful about who you share this with." Evan appreciated the warning, but he'd already decided. The evidence needed to be public. People deserved to know. He contacted several science journalists he'd worked with before. He offered them the story, exclusive access to all his documentation. One journalist was interested. She worked for a major magazine with a reputation for serious investigative reporting. They set up a meeting. That night, Evan's phone died. Not low battery, completely dead. Wouldn't turn on, wouldn't charge, just a black screen. He tried his backup phone. Same thing. Dead within minutes. His laptop shut down while he was working on it. Completely unresponsive. The hard drive was wiped, every file gone. His external backup drives locked themselves with encryption he hadn't applied, password prompts he couldn't bypass. His cloud storage accounts were deleted. All files vanished. In the span of 4 hours, every digital device he owned became useless. Every file he'd accumulated over 6 months of research was gone. Evan sat in his office, surrounded by dead electronics, trying to understand what had just happened. Then he saw the message. It appeared on his dead laptop screen. The screen that had been black and unresponsive seconds ago. White text on black background. No windows, no interface. Just text. "You're investigating a classified structure. This is your final warning." The message displayed for 5 seconds, then the screen went black again. Evan felt his chest tighten. They'd been watching him. They knew everything he'd been researching, and they just demonstrated they could reach into his personal electronics at will. He left his office immediately, packed a bag from his apartment, took only cash and paper documents, left all his electronics behind. He checked into a hotel in Cincinnati 2 hours from his home. He used a fake name and paid cash. He needed time to think. Someone had been monitoring his research, someone with resources beyond what he'd imagined, not just classified programs, not just government agencies, something with reach into private infrastructure, private companies, private networks. They could access his devices remotely, delete files across multiple platforms simultaneously, display messages on powered-down screens. That level of capability wasn't normal government surveillance. That was something else, something with backdoor access to fundamental internet infrastructure. Evan spent 3 days in hotel rooms, moving between cities, trying to figure out his next move. He couldn't use computers, couldn't use phones, couldn't access any of his research digitally. But he still had one thing. The original USB drive Laura had sent him, the one with the photograph. He'd kept it separate from his other backups, stored in a safety deposit box at his bank. He retrieved it and looked at the image again. The arc, the structure, the impossible object that shouldn't exist. This was the only copy left. Everything else had been erased. He needed to get this image out to the public before they found a way to delete it too. He went to a public library, used their computers with a VPN and multiple proxy servers, created anonymous accounts on multiple platforms, prepared to upload the image everywhere simultaneously. Before he uploaded, he wrote a brief explanation. Just the key facts, no speculation, just evidence. Then he uploaded everything at once. Reddit, Twitter, image hosting sites, conspiracy forums, file-sharing networks, everywhere he could think of. For about 4 hours it spread. People started seeing it, discussing it, analysing it, comparing it to other space photographs. The conversation was building momentum. Then it started disappearing. Post by post, platform by platform, the image was being removed. Not just his original uploads, the copies people had made, screenshots, downloads, everything. Within 12 hours, every instance of the image was gone. Even the people who'd saved it to their personal devices reported that the files had corrupted or disappeared. Evan tried uploading it, again from the library computer. His accounts were immediately suspended. Permanent bans, no appeals. He created new accounts. They were banned before he could post anything. He tried other libraries, other cities. Same result. Instant bans. Immediate removal. Whatever surveillance system he'd triggered was comprehensive. They were watching every public computer he accessed, every account he created, every file he tried to upload. The net was complete. Evan sat in his car in a library parking lot holding the USB drive, trying to figure out what to do next. He thought about the journalists he'd contacted. He called one of them from a payphone. She answered. "I can't talk about this," she said immediately. "I've been advised that the story isn't viable." "Who advised you?" "I can't say, but the message was clear. This isn't a story we're going to pursue. I'm sorry, Evan." She hung up. He tried the other journalists, same response. Polite refusals, no explanation. Just sudden disinterest in a story they'd been excited about days earlier. Someone had gotten to them, applied pressure, made it clear this story wasn't to be published. Evan had one option left: physical distribution. He couldn't rely on digital systems, but he could mail copies to people, create physical documentation that couldn't be remotely deleted. He wrote out his entire investigation by hand. 20 pages. Key facts, document references, contact information for everyone he'd interviewed. He made 10 copies at a print shop paying cash. He addressed them to 3 different journalists, 2 university researchers, 3 science writers, and 2 documentary filmmakers. People he trusted, people with platforms, people who might be willing to take risks. He mailed them from different post offices in different cities, used fake return addresses, spread the mailings across a week to avoid pattern detection. Then he waited. 2 weeks later, he started getting responses. Every envelope had arrived empty, just blank pages. They'd intercepted physical mail, opened the envelopes, removed the contents, resealed them, all without leaving evidence of tampering. That level of operational capability suggested resources beyond any single agency. This wasn't just the CIA or NSA. This was coordinated action across multiple systems: postal service, internet infrastructure, financial networks, media companies. Someone wanted this information buried, and they had the power to make it happen across every possible distribution channel. Evan realized he was dealing with something much bigger than he had understood. This wasn't just about a classified program. This was about controlling information at a fundamental level. Controlling what humanity was allowed to know about its own planet, and they were willing to use extraordinary measures to maintain that control. Chapter 5. The final attempt. Evan had one last idea. A peer-to-peer file-sharing network, the kind that distributed data across thousands of computers simultaneously, making it nearly impossible to eliminate completely. If he could get the file seeded into one of these networks, it would propagate beyond any single point of control. Even if they deleted most copies, some would survive. Eventually someone would notice. Eventually the evidence would reach critical mass. He spent his last free day preparing the file, the photograph, a written summary of his findings, excerpts from the documents he'd photographed, contact information for Margaret Reeves and Richard Torres, everything he could fit into a compressed archive. He encrypted it using open source software, set up a Tor node, prepared to upload it to multiple peer-to-peer networks simultaneously. He chose networks that were designed for exactly this kind of distributed archiving. Networks where files persisted even if the original uploader went offline. Networks that were used by journalists and activists to preserve documents that powerful organizations wanted destroyed. He initiated the upload from a coffee shop in Detroit. The file began propagating, node to node, computer to computer, each copy creating more copies, distributed across the network in fragments, no single machine holding the complete file. For 6 hours, it worked. The file spread. The distribution counter climbed. 10,000 copies, 20,000, 50,000. People started accessing it, downloading it, opening it, reading the evidence. Evan monitored the network activity from the coffee shop. He watched the counter climb, watched the geographic distribution spread across continents. Then it started dropping. Slowly at first, a few nodes going offline, then faster, hundreds of nodes, thousands. Something was sweeping through the network, deleting the file, not just from new uploads, from existing nodes, from computers that had already downloaded it. Evan watched in real time as the counter dropped. 50,000 copies, 40,000, 20,000, 10,000, 5,000, 1,000, 100, 0. They'd eliminated it from a distributed network, something that should have been technically impossible. They'd found a way to remotely delete files from thousands of individual computers simultaneously. The scope of that capability was staggering. That wasn't normal law enforcement. That wasn't standard intelligence agency power. That was infrastructure-level access, backdoors into operating systems, control over fundamental internet protocols. Evan closed his laptop and left the coffee shop. He didn't know if they could track his physical location yet, but he wasn't going to risk staying in one place. He drove to a park, sat on a bench, thought about what he'd learned over the past 6 months. A structure surrounding Earth, confirmed by multiple independent sources, nuclear tests in the 60s, radar mapping in the 60s, modern satellite observations, astronaut statements, all pointing to the same thing. A government cover-up spanning 70 years, classification, suppression, active denial, scientists silenced, programs terminated, evidence destroyed, and a surveillance and control apparatus capable of reaching into any digital system anywhere in the world to eliminate information they didn't want public. Evan pulled out his phone. He'd bought a new one, prepaid, cash purchase. He recorded one final message. "My name is Evan Mercer. I'm an aerospace historian. For the past 6 months I've been investigating evidence of a structure surrounding Earth at high altitude. Evidence that our government has known about this structure since 1958. Evidence that they attempted to break through it using nuclear weapons in 1962. Evidence that they've been hiding this truth for over 70 years. I've documented everything: historical tests, classified memos, scientific reports, modern observations. All of it confirms the same thing. There's a physical barrier at approximately 220 miles altitude. It's been there since before we had the technology to detect it, and our government decided we're not allowed to know about it. I've been threatened. My research has been destroyed. Every digital file I had has been erased. The people I interviewed have been silenced or have recanted their statements. Every attempt I've made to share this information has been blocked. But I need you to know something. The evidence is real. The structure is real. And they're hiding it because they know what it means. We're not explorers looking out at the universe. We're specimens being kept in. And someone decided a long time ago that we're better off not knowing that. He uploaded the video to a temporary hosting site. It lasted 40 minutes before being removed. Long enough for a few hundred people to see it, but not long enough to spread widely. Evan had one more thing to do. The USB drive with Laura's original photograph, the only copy that still existed. He couldn't distribute it digitally. They'd just delete it. He couldn't mail it domestically. They'd intercept it. But he had a friend in Norway, Lars Johansen. They'd met at a conference years ago. Lars worked at a small research institute outside Oslo. He was outside the American intelligence sphere, outside the immediate reach of whoever was suppressing this information. Evan packaged the USB drive in a waterproof case, addressed it to Lars at his institute, sent it via international express mail from a random post office in Indiana. Then he drove back to his apartment in Columbus. He knew what was coming. They'd let him run for weeks, probably watching to see who he contacted, what methods he tried, how far his information spread. Now they'd closed the loop. 2 men in civilian suits were waiting in his hallway when he arrived. Not police, not FBI agents with badges and warrants. Just two men who looked like they could be accountants or insurance salesmen, unremarkable, forgettable, except for their eyes, alert, trained, dangerous in a way that didn't require visible weapons. "Mr. Mercer," one of them said, "we need you to come with us." Evan didn't resist. He'd known this was coming. He'd done everything he could. Now it was out of his hands. "Where are we going?" he asked. "A debriefing facility. You'll be briefed on information classification procedures. You'll sign some documents. Then you'll go home. And if I don't sign..." The man smiled. It wasn't a friendly expression. "Then the debriefing takes longer, but the outcome is the same. You'll sign." They escorted him to an unmarked sedan. Dark windows, no government plates. Just an anonymous vehicle that could have belonged to anyone. As they drove, Evan looked out the window at the city passing by. He thought about Laura Benton, who disappeared after seeing that film reel. About Margaret Reeves, who'd told him about the structure and then recanted. About Richard Torres, who'd kept documentation for 40 years and finally shared it. He thought about all the scientists who'd seen the evidence and chosen silence. Van Allen, Christopoulos, Wolfe, Craven. Men who'd made careers studying space and then stopped asking certain questions. He thought about the structure itself, the massive arc in Laura's photograph, the radar returns in the Space Cave report, the modern satellite observations, 70 years of evidence, all pointing to the same impossible truth. Something surrounded Earth. Something that had been there longer than our space program. Something that someone had decided we weren't allowed to know about. And he thought about Dyson's handwritten note from the symposium. Not invasion, containment. That's what this was. Not protection from external threats. Containment of humanity. A barrier keeping us confined to our planet. The question nobody had asked yet was the most important one. Who built it, and why? Epilogue. The frame that survived. 3 months after Evan Mercer was escorted into an unmarked sedan, a package arrived at the Nansen Institute for Environmental Research in Oslo, Norway. Lars Johansen, atmospheric physicist, received the package at his office. It had been sitting in customs for 2 weeks before finally being released. No explanation for the delay. Just a stamp indicating it had been inspected and cleared. Inside was a waterproof case. Inside that, a USB drive. Inside that, a single image file and a text document explaining what it showed. Lars opened the image. His first thought was that it was another nuclear test photograph. He'd seen dozens of them. Declassified images from the Cold War. Nothing unusual. But then he read Evan's explanation. The date, the altitude, the structure that appeared for half a second during the flash. Lars enhanced the image, adjusted contrast, increased brightness, isolated the structure from the background radiation, and he saw what Evan had seen, a massive arc, regular curvature, defined edges, something solid at 200 miles altitude. But Lars went further. He had access to image processing software that Evan hadn't used. Software designed for analysing satellite imagery and telescopic observations. He applied spectral analysis to the structure, measured the light reflectivity, analysed the shadow patterns. The structure wasn't just a barrier, it had features. Lars zoomed in on the enhanced version. Behind the main arc, barely visible in the original, now clear after processing, were lights. Not stars. The wavelength was wrong. The pattern was wrong. These were artificial lights, arranged in patterns, geometric shapes, a grid. Lars felt his chest tighten. He zoomed in further. The lights were regularly spaced, precise intervals, mathematical regularity. And between the lights there were shapes, structural elements, what looked like support frameworks or attachment points. This wasn't a natural phenomenon. This wasn't even an accident of human construction. This was engineered. Someone had built this. Something had built this. Lars saved the enhanced image. He stared at it for 20 minutes, trying to wrap his mind around what he was seeing. A wall around Earth, a constructed barrier, covered in lights and structures, surrounding the entire planet. He thought about the implications. Every space mission had launched through this barrier. Every satellite that reached orbit had passed through it. Every astronaut who'd looked out the window had potentially seen it. And nobody had said anything. Or if they had, they'd been silenced. Lars reached for his phone to call colleagues, to share this, to start asking questions. Then he stopped. He thought about what had happened to Evan, the destroyed research, the deleted files, the intercepted mail, the men who'd taken him away. He thought about what Evan had written in his explanation. They will do anything to keep this secret. Be careful who you trust. Lars looked at the enhanced image again. The lights, the grid, the structure. Some truths he realised were bigger than one person's need to share them. Some truths required preparation, planning, the right moment, the right circumstances. If he published this now, it would be deleted like everything else. He'd be silenced like everyone else, and the evidence would be lost again. But if he waited, if he preserved it carefully, if he prepared the ground properly, someday conditions might change. Someday the control apparatus might weaken. Someday enough people might be asking the right questions that the truth couldn't be suppressed anymore. Lars deleted the enhanced image from his computer, but he saved it to 3 encrypted drives, stored them in separate locations, created detailed instructions for accessing them to be opened only if specific conditions were met. He wrote a letter explaining everything, sealed it, left instructions, with his attorney to deliver it to specific people if he died or disappeared. Then he went back to his normal research, atmospheric measurements, climate modelling, ordinary science. But every night he looked up at the stars and thought about what he knew, about the wall just beyond the edge of space, about the lights and structures that covered it, about the question that nobody was allowed to ask. If there's a barrier keeping us in, who built it, and why? The answer to that question, Lars suspected, was the real reason for the suppression. Not just that the barrier existed, but what its existence implied about humanity's place in the universe. We weren't the explorers we thought we were something else. And whoever built that barrier had decided we should stay contained, at least for now. Until then, the frame remained, hidden but preserved, encrypted but recoverable, waiting for the right moment, waiting for conditions to change, waiting for the day when humanity would finally be ready to learn the truth about what happened in 1962, about what our government discovered, about what still hangs above us, silent and watching, keeping us contained. The truth about the barrier, the truth about Operation Fishbowl, the truth about the wall we can't cross, and about the lights on the other side, the lights that suggest we're not alone, that we've never been alone, that something has been watching us, managing us, containing us, for reasons we're not yet allowed to understand. Someday someone will ask the questions again. Someday someone will find the evidence Lars preserved. Someday